Welcome to ScaleUp University. Welcome to the course on building applications with AI agents. So this is the lecture number 7 of module 2, and in this lecture we will be discussing orchestration, that is turning skills into systems. So this lecture is about orchestration, turning skills into systems. So let us look at the lecture overview, like what exactly we will be looking at in this lecture. So by the end of this lecture, you will understand how individual agent capabilities are turned into coordinated systems. So, how individual capabilities are turned into coordinated systems. So, if we talk about the individual capabilities of AI agents, like the tools, memory, reasoning, so how the individual capabilities, like the tools, memory, reasoning, all of that come together and turn out as a coordinated system. So that is what this lecture is about, orchestration. Orchestration is about making use of all the individual capabilities into a coordinated and turning the agentic AI system into a coordinated system. So that is what orchestration is. We'll also look at like how agents, they plan, execute, monitor, and adapt the workflow. So we will see the workflow cycle, like how agents, they plan, they execute, they monitor, and they adapt. And we will also discuss why orchestration is the central intelligence layer in agent systems. So orchestration as central intelligence layer. So if we talk about orchestration, it is the central intelligence layer in agentic AI systems. So that also we will look at. So all these things we will cover in this lecture, because this lecture is about orchestration, turning skills into systems. So we will see how individual capabilities of an AI agent, like the tools, memory, reasoning, that turn out to be a coordinated system. We will understand the workflow cycle, how AI agents, they plan, execute, monitor, and adapt. And we will also get a realization of orchestration as central intelligence layer in agentic AI systems. So in this lecture, we will be discussing topics like what orchestration actually means, composing multi-step workflows, planning skill sequences, monitoring progress, dynamic replanning, incremental planning, supervising tool execution, adapting to environment changes, ensuring step alignment toward goals. Why orchestration is the backbone of agent systems, real world orchestration patterns, and end to end practical example. So, all these topics we will cover in this lecture itself one by one. So, this is the lecture 7 of module 2. Module 2 is designing agent systems, and this lecture is orchestration, turning skills into systems. And we are starting with the first topic of today's lecture, that is what orchestration actually means. So let us look at what orchestration actually means. So if we talk about the definition of orchestration, so orchestration is the process of coordinating multiple components, like the tools, models, memory, APIs, to achieve a goal through structured execution. So if I talk about orchestration, it is the process of coordinating multiple components of an agentic AI system. So orchestration is the process of coordinating the tools, the models, the memory, the APIs. And why we are coordinating to achieve a goal through structured execution. So that is what orchestration is. So if I talk about orchestration, orchestration is basically the nervous system of the agentic AI system. We already know that the large language model is the brain. The large language model, LLM, is the brain of the agentic AI system. Tools are the hands. So orchestration is the nervous system which connects the brain with the tools and the memory. So that is what orchestration is. So orchestration is basically the process of coordinating multiple components of an agentic AI system like the tools, models, memory, APIs, and to achieve a goal through structured execution. So that is what orchestration is. So if we talk about the core idea of orchestration in agentic AI systems, so the core idea of orchestration is, so orchestration is decision layer plus the control flow plus the execution logic. So the idea is that the large language model, it will receive the input query, it will decode the intent, and based on the intent, based on the goal to be achieved, it will make a plan. So decision layer is all about making the plan. Decision layer is all about reasoning, planning. So in orchestration, we start with a plan, a reasoning, a planning. And then let us suppose if I want to accomplish a complex goal, then I will be breaking that into multiple steps. And that is where the control flow will come into the picture. Breaking a big task into small steps and then executing each of the steps. So now orchestration is very clear to us. When I talk about orchestration, I am talking about decision layer. I am talking about planning, reasoning. Like whatever the goal is to be achieved, I will make a plan. A large language model will make a plan for it. Then we will break the plan into small steps. So that is the control flow. Breaking it into steps, multi-step task, and then execution, executing each of the tasks. So that is what orchestration is all about. So orchestration is decision layer plus control flow plus execution logic. So this is the core idea behind orchestration. So when I talk about orchestration, I'm talking about deciding what to do. I'm talking about control flow, how to do, like what structure I will be following, what steps I will be following, and the execution logic. So that is what the orchestration, the core idea of orchestration. Now let us look at the decision layer. So in orchestration, we start with the decision layer. So decision layer is like the planner. So in orchestration, the system evaluates the goal at every step. So in orchestration, the goal is evaluated at every step. So agentic AI system, it evaluates the goal at every step. Like at every step, it checks whether it is approaching towards the goal or it is drifting away from the goal. So the system, the agentic AI system, it evaluates the goal at every step. So two things are involved. One is the dynamic planning and the self correction. So in the decision layer, two things are being taken care of. One is the dynamic planning and another is the self correction. If I talk about dynamic planning, so so basically breaking a complex prompt into subtasks. That is what dynamic planning is. So the idea is that I want to achieve a big goal. So in order to achieve a goal, I have to break that goal into subtasks. So that is what dynamic planning means. So in orchestration, I will be doing dynamic planning and I will be doing the self correction. So in the decision layer of orchestration, we will be doing dynamic planning and self correction. So dynamic planning means breaking the complex prompt into subtasks like the, so that is the decision layer of the orchestration. And in self-correction, the idea is that if tool returns error, then the orchestration layer will decide whether to retry. So if the tool returns any error, then the self-correction means the orchestration layer will decide whether to retry, execute the tool once again, or try different tool, or ask user for some clarification. So that is the idea. So now it's very clear that if I talk about the decision layer of the orchestration, it is also called as the orchestration layer, the planner. So here we do the dynamic planning wherein we break the complex prompt into the subtask, and the orchestration layer, it also takes care of the self correction wherein if tool returns any error, the orchestration layer, it decides what to do, whether to retry or to try a different tool, or whether to ask for clarification. Control flow, the control flow layer of orchestration. So control flow is the logical layer of orchestration. So this is how the system moves between states, because we know that we break a goal into subtasks. So how the system moves between states is what is decided by the control flow. So in control flow, basically there are three common shapes of orchestration. So the first is the linear. We also call it the chain. So the control flow can be linear, the chain. So in linear, it's basically a simple sequence. So the idea is that as linear means the output of tool A becomes the input of tool B, and like that. We can also have parallel execution. So the idea is running multiple tasks at once. So as we started, at the same time, we are running task 1 and task 2. For example, task 1 is searching Google and task 2 is searching Bing. So running task 1 and task 2 simultaneously and merging the results. So that is what is the parallel is. So we are discussing the control flow. Control flow can be linear, it can be parallel, and the control flow can also be cyclic, the loops. So in cyclic control flow, the agent keeps trying a task until a specific success criterion is met. So keep editing this code until it passes the unit test. This is an example. So cyclic, the idea is very clear. We start with a test, we start with a task, and we keep on retrying, executing that task until a success criterion is met. If the success criterion is met, we are done with the task. And if it is not met, we will retry. So that is the cyclic. So now the control flow is clear to us, because if we talk about orchestration, so control flow is the logical layer of the orchestration wherein the control flow, it decides how the system moves between the states. And we have three very common control flow. So if we talk about orchestration, it can be a linear orchestration wherein step by step, a simple sequence. It can be parallel. It means at a time, multiple tasks are running at once, and the, later we are merging the results of the task. And the orchestration can be cyclic, wherein the agent keeps trying a task until a specific success criterion is met. So now we will discuss the context and memory management, like how the orchestrator, it deals with the context and memory management. So orchestration is not just about doing things, it's also about remembering. Orchestration is not just about doing things, it's also about remembering. So in orchestration, we also do the state management and information filtering. So if I talk about state management, the orchestrator, it keeps track of what has already been tried. so the agent does not get stuck in a loop. So state management is all about keeping track of what has already been tried, so the agent does not get stuck in a loop. So that is what state management. So state management means whatever responses we are getting, we are storing it, or whatever steps we have taken, like the orchestrator, it will make a plan, it will decide a control flow, whether to go for a sequence or linear control flow or parallel execution or cyclic. So whatever steps or whatever the plan the orchestrator has made, or whatever the control flow logic it has decided, whatever responses it got, everything it will store. And that is what the state management is. So keeping track of what has already been tried. So that is state management. So the idea is that, like, we can understand it with a example, like let us suppose agent, it attempts a task and it failed, then it will retry. Now this, it will register it, it will store it somewhere, so that the agent, like we are storing it, that okay, agent tried a task and it failed and it retried, and once again it failed. So every time it is getting failed, that state, we are storing it somewhere in the memory. So that is what state management is. So the idea is that this can be very helpful for the large language model in the long run, because large language model, it is like storing the experiences. Large language model will get to know that okay, I tried this approach many times, but every time I got failed, so now I should try a different approach. So with state management, our system will become more experienced, it will learn from the real world experiences, because we know that large language model, it already has got a knowledge. Large language model, it already has got state of the art knowledge. It has knowledge of all the books, all the resources, but it is missing the experience of the real world, because we know that in our agentic AI system in the real world, a tool might behave in an uncertain way, and that real world experience, we can make use of it if we store the experiences, if we store the state. Then our large language model will become very smart, it will learn in the real time that okay, this particular, like if I follow this approach, then I'm not getting the result, so I should try a different approach. So that is what state management is all about. If I talk about information filtering, so the orchestrator, it decides which parts of a massive API response are actually important to pass on to the next step, preventing context window clutter. So the idea is that, let us suppose we are getting massive API response, like the raw data. Now definitely we cannot fill all of the response into the context window, because the size of the context window is limited. So here the orchestrator will do the information filtering. So the orchestrator will do the information filtering, wherein it will decide what to include. So from the massive response, important context for the next step, the orchestrator will decide. So that we call as the clean data. So the orchestrator, it decides which parts of a massive API response are actually important to pass on to the next step, preventing the context window clutter. So in this way, the orchestrator plays a role in memory management and context. So effective orchestration, it relies on maintaining context and filtering information to optimize agent performance and prevent redundant actions. So that is what context and memory management, like how the orchestrator does the context and memory management. Execution logic, the handshake. So if I talk about orchestration, orchestration also handles the execution logic. So execution logic is the technical glue. So basically the orchestration, if I talk about, it handles the authentication. Orchestration, it handles the authentication and the data formatting. So if I talk about authentication, passing the right API keys to the right tools. So this is been taken care by the orchestration layer. So orchestration layer, it also takes care of the execution logic, and in particular it takes care of the authentication, wherein the orchestration layer is responsible for passing the right API keys to the right tools. Because we know that if we talk about third party tools, they might need some API keys, and in our agentic AI system there might be a secret manager which is containing all the API keys, and the orchestration layer will just be responsible for passing the right key to the right tools. So securely delivering the right keys to the right tools is the responsibility of the orchestration layer. Orchestration layer is also responsible for data formatting. So converting the AI's natural language output into a JSON format. So let us suppose we know that the output of the large language model is like a natural response. Now the orchestration layer, what it will do, it will convert the natural language response into a JSON format like this, which the database can understand. So transforming human language into structured software input. So this is an example of a data formatting, and this is what is been taken care by the orchestration layer. So orchestration layer also handles the execution logic, wherein it takes care of the authentication and data formatting. Now let us discuss the importance of orchestration. Like why orchestration is so important, why it matters right now, why orchestration matters right now. So in the world of agentic AI, we are living in the world of agentic AI. We are moving away from prompt engineering towards flow engineering. So we can see a transformation. We call it like the agentic AI shift. So we are shifting from prompt engineering to flow engineering. So we know that prompt engineering is all about finding the right words or giving the right words to the large language model. That is prompt engineering. And what is flow engineering? Flow engineering means building the right orchestration. So now we are not talking about giving the right prompts, but now we are talking about giving the right orchestration. And that is what the flow engineering is. And we are shifting from prompt engineering to flow engineering, and hence we can realize the importance of orchestration, because now the the word of agentic AI is focusing on building the right orchestration, and this clearly is indicating the importance of orchestration. If we talk about prompt engineering is all about like finding the right words to be given to the large language model, and prompt engineering is like very like it's too simple, brittle, and it does not scale. But if we talk about flow engineering, which is the new paradigm, flow engineering is all about building the right orchestration. So building the right orchestration. So we will be building the orchestration layer. So orchestration is all about managing the agentic AI components or the capabilities like the tools, the memory, the models, and also different agents like specialized agent A, specialized agent B. So coordinating other agents, external tools, memory systems, human in the loop, input, output, large language models. So that is what is orchestration is. So the orchestration layer takes care of that coordination. Orchestration layer, it takes care of planning. It takes care of the execution, the control flow, monitoring, self correction. So that is what flow engineering is. And now we are heading towards the era of flow engineering. So the key takeaway is a mediocre model with great orchestration will always outperform a genius model with no coordination. So for agentic AI system, it's about system and not just model. It's not just about using genius model. Rather, it's more about great orchestration. So great orchestration is more important than a genius model, because a genius model with no coordination is of no use. But a mediocre model with great orchestration can be of great use. So that's the idea. Composing multi-step workflows. So now we'll discuss composing multi-step workflows. So let us first understand, why do we need multi-step task handling? What is the need for multi-step task handling? So most real world tasks, they are not single step. Rather, they involve multi-step task handling. For example, if we consider the task of refund a damaged product, like let us suppose we ordered a product, we got a damaged product. Now we have to refund it. We have to return it back and get the payment back for that particular product. So if we talk about this real world task of refund a damaged product, it is not a single step task. Rather, this particular task, it involves multi-step. Like first we have to understand the request. Then we have to validate the order. We have to check whether that order exists or not. We have to validate the order. Then we have to check the return policy. Is that product is eligible for return? Like the duration 30 days, 15 days. So return policy. And if the product falls in the return policy, then we have to call the refund API and confirm it to the user. So this real world task of refund a damaged product, it involves so many steps. So it is a multi-step task. So this example, it clearly highlights why a single prompt, like why a single large language model response is not enough. So it's not a single step task. So if we look at the complexity of this task, so a single prompt cannot know if a user is lying or if the warehouse has the item in the stock or not. So a single prompt can't know if a user is lying, because we have to validate the order. So for that, multiple prompts will be needed, like multi-step will be needed. In a single step, it is not possible for us to first validate the order and also check the inventory, whether the new product is available in the warehouse or not. So real world tasks, they are complex by nature. And there is also a dimension of safety and accuracy, because if we break the task down, by breaking the task down, the system adds guardrails. So for example, it won't trigger a refund API unless the check policy step returns a success flag. So if the check policy step, it returns a success flag, then only the call refund API will be called. So with multi-step task, we are by default, like automatically we are adding guardrails. Like if a particular condition is met, then only execute a tool or call a API. So guardrails, and it will add, it will make our agentic AI system more safe and more accurate. So with multi-step task handling, we are able to deal with the complexity. We are able to achieve safety and accuracy, and we are also able to achieve reliability. We are also able to achieve the reliability. So the idea is, small specialized tasks are less likely to produce hallucinations than one massive complex prompt. So just imagine if you are trying to achieve a lot in one single step. In that scenario, that large task, that one massive task, one massive complex prompt can definitely hallucinate your large language model. It can produce errors, or it cannot it can drift away from your goal. So small specialized steps are less likely to produce hallucination. So small specialized steps will always give us the right results. Models will not hallucinate with small specialized steps. So that's the idea. So reliability. So now it's very clear that if we talk about multi-step task handling, we will be able to deal with the complexity, safety. We can make our agentic AI system more safe and accurate, and our agentic AI system can become more reliable. So now the importance of multi-step task handling is very clear to us. Most real world tasks are by complex by nature. They cannot be handled in a single step. We do need multi-step task handling, and with multi-step task handling we also achieve safety, accuracy, and reliability. So that's the importance of multi-step task handling in agentic AI systems. So we have to break the task into small subtasks and execute those subtasks to and merge the results to get the to achieve the final goal. Now let us discuss workflow types, like the multi-step workflows, different types of multi-step workflows, the architectures. So now we will discuss different types of uh, multi-step workflows, different like architectures of it. So we can have the sequential workflows, the chain sequential workflows. So in sequential workflows, this is basically a linear path. If any link breaks, the process stops. So the sequential workflow is a linear path. Like we'll start, then step A, step B, step then end. And if any step breaks, if any links breaks, the process stops. It gets stuck. And if we talk about some use cases of sequential workflows, language translation is like a very interesting example of a sequential workflow. So language translation followed by sentiment analysis. So first we will do the language translation, then we do the sentiment analysis. This is a sequential workflow. First complete this task, then the result of the previous task give it to the next task. So language, we will first translate the language, and the translated language we will give it to the sentiment analyzer, and we'll do the sentiment analysis of it. So it's a sequential workflow, one after the another. So LLM summarizes a transcript, then the summary is passed to the tool, and that tool will create a calendar invite based on the content of it. So that is how the sequential workflow works. So sequential workflow is also dynamic in nature. So this is very important. It is not fixed or rigid, rather it is dynamic. The dynamic in that sense that in the real time it will decide what next step to be taken. It's not like it's something fixed that always a particular sequential workflow will be followed. So now it's very clear that this sequential workflow is dynamic in nature. So based on the current action, like based on the current step, the next step will be decided. So that is what the sequential workflow is. We can also have parallel workflows, the fan out. So in parallel workflows, multiple steps or multiple tasks, they will execute in the same time. So this is about speed and breadth. So the agent kicks off multiple tasks at once. So in parallel workflows, our agent will execute multiple tasks at once. So task 1, task 2, task 3, they are running simultaneously. So that's the parallel workflow. And we have a coordinator which will coordinate this task and aggregation. The result of these tasks, we will aggregate it. So the use case of parallel workflow is compare prices for flight on 5 websites. So we will visit 5 websites at the same time and we will fetch the flight price and compare it. So it is an example of a parallel workflow wherein in the same time we are visiting the 5 websites, getting the flight price and comparing it. And here aggregation plays a role which will merge the results into single report. So the results of every task is been merged into a single report by the aggregator aggregation. We can also have conditional workflows, the decision trees. So in conditional workflows, the agent acts as a router, choosing a path based on the logic. So based on the logic, the path will be decided. So the agent will act like a router. If this, then that. So if user is angry, then bring the human in the loop, route to human. Else automate the troubleshooting. So this is the conditional workflow. So we are discussing an example of a customer support bot. So initially customer support bot is trying to troubleshoot a user's problem, and after every response it will check whether the user is happy or not. If the user is not satisfied, if the user is angry, it will route the control to the human. Otherwise it will continue with the automated troubleshooting. So it's an example of a conditional workflow, the decision tree. Then we can also have hierarchical workflows, the manager worker. So in hierarchical workflows, we will be having an hierarchy wherein there will be a manager who will be managing the workers. So the manager agent, so the manager agent will receive the high level goal. Manager agent receives the high level goal and delegates the specific parts. So the manager agent will receive the high level goal. It will break that goal into subtasks and delegates the specific parts, the subtask, to the workers. So the worker agents can be specialized agents like researcher, writer, editor. So this is how the hierarchical workflows they work. So the manager worker. So the idea is that the manager agent will receive the high level goal. Manager agent will break it into subtasks and it will delegate the specific parts, the subtask, to the worker agents. Now the worker agents can be the specialized agents like the researcher, writer, editor. And hierarchical workflows, they have many use cases like writing a software documentation manual. So the manager delegates technical specifications to researcher, formatting to writer, and so on. So this is the hierarchical workflows. Now in multi-step workflows, orchestration is the key concept. Orchestration enables multi-step workflows. And let us see how. The key concept, orchestration. So basically orchestration is the brain or the engine that manages multi-step workflows. Orchestration is the brain or the engine that manages the multi-step workflows. If I talk about some examples like LangGraph, True AI, AutoGen. So these are the engines, LangGraph, True AI, AutoGen. These are the brains or the engine that manages the multi-step workflows, orchestration. So orchestration ensures that state is maintained. So orchestration remembers the state. Like it remembers, it ensures that state is maintained. It remembers what happened in step 1 while performing step 4. Orchestration ensures error handling. So if let us suppose any tool fails, so the orchestrator decides whether to retry or ask the user for help. So if a tool fails, orchestrator will decide whether to retry or go for any other tool or bring human in the loop or ask clarifying questions. Error handling is being taken care by the orchestration, and orchestration ensures efficiency. Orchestration ensures the right tools is used at the right time, transforming a vague intent into a precise executable plan. So let us suppose we have a vague intent. Help me with my order. Now orchestrator will convert that vague intent into a precise executable plan. So orchestrator will refer that it will do the database lookup to get the exact details of the order the user is talking about. It will call the payment APIs, shipping service, and it will create a precise plan to transform the vague intent into a precise executable plan. Efficiency. So orchestrator is responsible for that. Orchestration ensures the right tool is used at the right time. So now it's very clear that for like multi-step workflow, in multi-step workflow, orchestration is the key. Orchestration is the engine, the brain that manages the multi-step workflows. Orchestration ensures the state is maintained, error is handled, and orchestration ensures the efficiency. It orchestration transforms a vague intent into a precise executable plan. So orchestration transforms intent into executable workflow because orchestration takes care of planning, reasoning. So whatever intent it got, it will make a plan for it. It will make an executable workflow. Planning skill sequences. Now we will discuss planning skill sequences. So let us first understand what is planning. Let us understand what is planning. So basically, planning is the reasoning phase where a large language model acts as an architect. So planning is the reasoning phase where the large language model acts as an architect. So in agentic systems, planning is the cognitive bridge between a high level user request and the physical execution of code or tools. So in agentic AI systems, we have high level user requests and we have to accomplish the goals. We have to serve the high level user request. So there the planning plays the role of cognitive bridge. So planning is the cognitive bridge in agentic AI systems. Planning is the cognitive bridge which takes in the high level user request and transforms into executable workflow, physical execution, the code, the tools. So planning is about transforming the user request into the executable workflow. That is what planning is in agentic AI system. Planning is the cognitive bridge. Planning is the process of decomposing a complex what into a structured how. Because we start with the what, like user will tell, this is what I want, this is what I want, this is my query, or this is what I want to accomplish, this is what I'm looking for. So planning is about decomposing a complex what into a structured how. Planning is how to accomplish a goal, a structured how to accomplish the what which the user is seeking. So decomposing a complex what into a structured how is what the planning is in agentic AI systems. So instead of immediately generating a response, the agentic AI system it pauses to map out a sequence of actions, and that sequence of actions is what the planning is. So planning involves goal decomposition. Planning involves goal decomposition, breaking a vague objective into atomic manageable subtasks. That is what the goal decomposition is. For example, if the goal is organize my trip, now it is a vague goal, organize my trip. And goal decomposition, we will break it into subtasks. Like to organize your trip, we have to book flights, we have to find hotel, we have to create itinerary. So that is what the goal decomposition is. And planning involves sequencing, determining the dependencies. For instance, you cannot initiate refund before you identify order. So sequencing. So we have the subtask, and now we will arrange them in an order. So that is what sequencing is. So in order to initiate refund, first we have to validate the order, identify the order. So that is what the sequencing is. So we know that in order to accomplish a big goal, I have to perform these subtasks, but in what order is what is sequencing is. So sequencing is the order. So planning is all about deciding which steps to take and in what order. So planning is about goal decomposition, like what subtask or what steps I should take and in what order. So in agentic AI systems, if I talk about planning, two things I have to take care of: goal decomposition, like whatever the objective is, whatever the what is, I have to break it into task, subtask. So goal decomposition and also the sequencing, the order. So that is what the planning is in agentic AI systems. Now let us look at some planning strategies which we should consider while orchestrating planning strategies. So we can have static planning. So static planning is like the blueprint. So in static planning, the developer hard codes the sequence of steps. So the developer he hard code like fixed SOPs, like systemic operating procedures, fixed SOPs, hard coded sequence. That is what the static planning is. So the agent follows a fixed standard operating fixed standard operating procedures. So for example, if the intent is password reset, so there is a SOP for that. Like to reset the password, follow step A, then step B, then step C. So that is what the static planning is. Hard coded sequences. And how it works, every time a specific intent is detected, the agent follows the fixed standard operating procedure, fixed steps. So static planning, it is best for regulated industries. It is best for fixed workflows, fixed SOPs. It is best for regulated industries like the banking, the healthcare. It is best for predictable tasks, repetitive tasks where deviation is a risk. Now, what are the pros of static planning? High reliability, because we know that fixed workflow, so very high reliability and safety and easier to test. And what are the cons? It is brittle, it cannot handle uncertainty, it fails off script. If the user asks for something slightly off script, the agent may fail. So that is what the static planning is. So in planning strategies, we also have dynamic planning, which acts like the navigator. So in dynamic planning, the agent generates the plan at the runtime based on the specific nuances of the user's prompt and the current state of the environment. So in dynamic planning, the agent generates the plan at the runtime based on the context, the tools, the current environment, and the user's prompt. So how it works, the dynamic planning, the agent assesses the context. So the agent assesses the context. It looks at its available tools and builds a custom roadmap. It can replan midway. That is what the beauty of dynamic planning is. We can keep on reiterating. We can replan midway if a step fails or if the user changes their mind. So in dynamic planning, we can handle uncertainty. All of a sudden, let us suppose the user wanted a trip to London, and all of a sudden the user changes his mind and is looking for a trip to Paris. So with dynamic planning, we can handle that kind of a change. We can replan midway, because here there is no fixed SOP we are following. There is no hard coded sequence of steps. Rather, we are generating the plan at the runtime based on the context, based on the user prompt, based on the tools which are available to us. Let us suppose all of a sudden a third party tool it stop operating. Something wrong has happened to it. So with dynamic planning, we can handle those scenarios as well. So that is what the dynamic planning is. So dynamic planning, it is best for open-ended research. Dynamic planning is best for creative tasks and complex troubleshooting. So the pros of dynamic planning is very flexible, intelligent, and the drawback is high latency, higher latency. It takes more time to plan. It might hallucinate. So prone to hallucinated steps or infinite loops. So we can also have infinite loops if not properly bounded. So if dynamic planning is not properly bounded, it might it is prone to infinite loops or hallucinated steps. So that is the cons of dynamic planning. Now let us look at an example breakdown. So let us look at an example like how planning works. So orchestration layer, it is responsible for planning. So let us look at with an example how planning works in Agentic AI system. So we have an example like cancel my order and refund it. So this is the query from the user, and this query is like very vague because user is not at all telling which order. So just the user is giving a prompt cancel my order and refund it. So in a dynamic scenario, the agent's internal logic might look like this. So the dynamic planning we are discussing. So the agent, he will, it will first try to identify the order, because cancel my order, it's very vague. So the user will try to identify the order. So the agent will call the get user orders function to find the most recent transaction, and then the agent will check the eligibility, whether that order is eligible for refund or not. So the agent will compare the purchase date against the refund policy database. And if it is eligible, then the agent will cancel the order. The agent will call, so if the order is eligible for refund, it will call the update order status API to cancelled. Then the agent will initiate refund. It will trigger the payment gateway API to return refunds. And finally, the agent will notify the user. So it will synthesize a final confirmation message for the user. So this is how a dynamic planning works like. So we had a task like cancel my order. So this is the what the user want. User wants to cancel the order and get refund. And planning is the how, and how we will achieve that. So step by step. So goal decomposition and ordering. So in planning, two things are there: goal decomposition and sequencing, ordering. So we have step by step subtasks which should be followed in this order. Ordering is very important. If we don't follow the order, it will not work. So first we will identify the order. We'll check the eligibility, whether it is eligible for refund. And if it is eligible, we'll cancel the order, we'll initiate the refund, and we'll notify the user. So this is how the planning works. So the key idea of planning is from ambiguity to action, from vague intent to executable workflow. So from ambiguity to action is the key idea of planning. So planning is breaking the goal into actionable steps. That is what the planning is. So user, like the agent will be given a goal. It can be a vague goal, and breaking the goals into actionable steps. The goal decomposition is what the planning is. And goal decomposition and also ordering of these steps. That is also equally important. So breaking the goals into actionable steps and ordering them, and then executing it in a particular order. So that is what the planning is. So the core value of planning is it prevents action paralysis. It prevents action paralysis. By breaking the goals into actionable steps, the agent transforms a high level human desire into a series of discrete, low level technical instructions. So, planning is about transforming the high level human desire into a series of discrete, low level technical instructions, executable workflows. So, that is what the planning is. Now, we will discuss monitoring progress. So, monitoring progress. So, let us first understand why monitoring matters. So, monitoring is like navigating the uncertainty. So, let us understand the importance of monitoring. So, monitoring is the nervous system of an AI agent. So, see, planning creates the map, because if we talk about planning, planning will tell that how to achieve a goal step by step and in a particular order. So, ordered sequence of steps that should be taken to to achieve the goal. That is what planning is. So, planning is the map. So, planning creates the map, and monitoring provides the real time GPS signal. So, monitoring is like the real time GPS signal whether we are on the right track. So, monitoring provides the real time GPS signal to ensure the agent does not drive off a cliff when the environment changes. Monitoring ensures that agents they don't drift away from their goal. So monitoring is like keeping a check on the goal, like are we still on track? So that is what the monitoring is. Because unlike traditional software, agentic AI systems they operate in non-deterministic environments. Agentic AI systems they operate in non-deterministic environments. Now these non-deterministic environments they are prone to external changes. So a website might change its layout, or an API might go down. So non-deterministic environment, agentic AI system is prone to external changes, and their monitoring plays a very important role. Let us suppose all of a sudden a API fails. So with monitoring, we get to know that okay, this API or this tool is not working. Then because of dynamic planning in the midway, we can change the plan. We can go for any other tool. We can go for an alternate tool. So that is the idea. LLM variability. So if we talk about non-deterministic environments, we have LLM variability. So the AI might follow instructions perfectly one time and get confused the next time. So that is what the inconsistent responses is. And human intervention. A user might provide a mid-process correction that contradicts the original plan. So human intervention is a part of non-deterministic environment. All of a sudden, human might intervene and might provide a mid-process correction that might contradict the original plan. So now it's very clear that let us suppose the agent made a plan and now it is executing that plan. But the agent AI system, it lives in a non-deterministic environment. All of a sudden, a tool might fail, or LLM might give a inconsistent response, or a human might intervene. Because of these non-deterministic environment, there is a need to constantly keep an eye or keep a check whether the agent is in the right track, or is it getting drifted away from the goal, and there monitoring plays the role. So monitoring is like the real time GPS which is keeping a track that okay, whether we are still on track, we are heading towards the goal, and if at any point we are drifting away from the goal, if at any point we are drifting away from the goal, then agent has to replan. In the midway, it has to change the plan. It has to update the plan. So monitoring ensures the agent knows exactly where it stands at every milliseconds. So that is what the importance of monitoring is. So monitoring is very important for orchestration also. So if I talk about orchestration, monitoring progress is very important. So now it's very clear why monitoring matters. Because monitoring ensures the agent knows exactly where it stands. Monitoring ensures that we are heading towards our goal. We are still on track. Now let us discuss what to monitor. Like in agentic AI systems, what we should monitor, the vital signs. So what an agent should monitor. If we talk about an agent, so to keep an agent on track, the system tracks four critical data points. So the first is the step completion. First, we have to monitor the step completion. So did the agent finish the subtask or did it time out? So whether a particular subtask is been completed by the agent or not. So that is the step completion. Like subtask C completed in 2 seconds versus subtask C timed out after 10 seconds. So this we have to monitor whether a particular step subtask got completed or not. Step completion. This is a vital sign. Now the next important critical data point or the vital sign that we should monitor is tool success or failure. Let us suppose we called a particular tool. So did the API return a 200 OK or a 500 error? So whether the tool execution was success or failure. Did the API return a 200 OK or 500 error? An agent must know if a tool failed. So it does not try to use a non-existent output in the next step. So with this, the agent avoids using non-existent output because if the tool failed, then definitely we haven't got any valid response and we cannot pass it to the next step. So agent avoids using non-existent output by monitoring the tool success or failure. And next, very important critical data point, the vital sign which we should monitor, which the agent should monitor, is the state transitions. It should monitor the state transitions. Does the current state, the agent memory accurately reflect the work done? So we should monitor whether the current state reflect the work done. So let us suppose initially order cancelled parameter is false, but after successful completion of the cancellation step, we have to update the order cancelled to true. So state transition, we have to keep on monitoring whether the state transition occurred or not because a particular subtask or a step got executed, it has to update the state. So state transitions we should monitor. State transition, monitoring state transition is like memory accuracy check. We are keeping an eye on the memory accuracy. And next important vital sign, the critical data point we should monitor is the goal progress. Is the agent getting closer to the final goal or is it stuck in a loop repeating the same step again and again? So this we should monitor goal progress, whether the agent is getting closer to the final goal or it is stuck in a loop making mistakes again and again. So now it's very clear that if I talk about what to monitor, so the agent should look into monitor four critical data points, the four vital signs. First is the step completion. Did the agent finished a particular subtask or not? Then the second vital sign is the tool success or failure. The third vital sign is the state transitions. So if a particular step got executed, whether the state got updated or not, state transitions. And the next very important vital sign which the agent should look at, the agent should monitor is the goal progress. If whether the agent is getting closer to the final goal or whether it is stuck in a loop. Now let us discuss the monitoring techniques. the oversight tools, like how we can monitor, like in agentic AI systems, what are the monitoring techniques we should adopt. So the first important monitoring technique is the execution logs. So execution logs are the detailed black box records of every prompt sent to the LLM and the response received. So detailed black box records. So every prompt sent to the LLM and every response and also the steps taken needs to be logged, and the log of it is the execution log. And execution log is very important for debugging because execution log will give us an idea about what was given to the LLM and what was the response and what steps it took. So that is what the execution log is. So with execution log, we can monitor the agentic AI system. We can monitor. And to monitor, we can also go for state tracking. So we should maintain a centralized database, which is also called as the short-term memory. And this centralized database will store the variables and context across different steps. So that is what the state tracking is. So to monitor, we should have execution logs. We should have the state tracking. For state tracking, we will maintain a centralized database wherein we will store the response of every step. We will store the variable, the context across the steps. And for monitoring, we will also do the intermediate checkpoints. So what are intermediate checkpoints? We will be like, it's like saving the game at critical junctures. So intermediate checkpoints means saving the game at critical junctures. So the idea is that while the agentic AI system is in, it's running, it's executing at critical junctures, we will be saving the state so that if agent fails at step 9, we can restart from the checkpoint at step 8. So saving the state at critical junctures so that if the agent fails at step 9, it can restart from the checkpoint at step 8 rather than starting the entire task from scratch. So let us suppose an agent wants to accomplish a big goal. So in order to accomplish a big goal, it breaks the goal into 10 steps. Now, after successful completion of every step, we can save the state so that if the next step fails, we can just start from the previous step and not from the beginning. And that is what the intermediate checkpoints is. So now it's very clear how to monitor. The techniques for monitoring is like we should maintain an execution logs. Every prompt sent to the LLM, the response of the LLM, the steps taken. We should maintain the state tracking. We should maintain a centralized database storing the variables and the context across steps, and intermediate checkpoints like saving the states or the results of the step or the state at critical junctures. So these are the techniques for monitoring. Now let us look at an example of the recovery loop. Example of the recovery loop. So we are looking at an example of monitoring progress. So the scenario is a refund process. So we know that for a refund process, first we will validate the order. We will check whether the order is valid or not. So if the order is found, so the order ID will be the state. And the step 2 will be uh, invoking the payment gateway, like calling the refund API. And let us suppose the refund API failed. There was some issue with the payment gateway and we got an error, payment gateway timeout. So in step 1 was successful, but step 2 we got an error. So this is how the monitoring works. Now it's very clear that every step we will keep on monitoring whether the step got completed, and if step 1 got completed, then only we will be moving to step 2. And how we will decide? Because of monitoring. We are monitoring every step. So the monitoring response, if we talk about, instead of telling the user, I am sorry, I cannot help, a monitored agent sees the failure and triggers a recovery strategy. So this is the importance of monitoring. Because of monitoring, now the agent exactly knows where the fault is, and it can go for a recovery strategy rather than halting the system and throwing an error. The agentic AI system, because of monitoring, it will be able to debug. It will know exactly where the problem is, and in the runtime, it can trigger a recovery strategy. And in recovery strategy, like let us suppose there was a failure, then the agent can trigger a recovery strategy. In recovery strategy, it can go for a retry. It can attempt calling the same API after 5 seconds. So attempt API call after 5 seconds. So that's a retry. It can go for an alternative path. It can use a different payment gateway or different APIs for the payment. And still, if some problem is there, it can flag task for human agent. It can bring human in the loop. And the third recovery strategy can be graceful feedback. If none of the strategy is working, it can give a graceful feedback to the user that I have cancelled the order, but the refund is pending due to a system delay. I will try again in an hour. So these are the recovery strategies. So now it's very clear that if I talk about the recovery loop, very important it is. So because of the monitoring in place, we can recover from an error. So let us suppose in a particular step, something wrong happened. Because of monitoring, the agent will get to know that, okay, this step, there was an issue. Then the agent can trigger a recovery strategy wherein the agent can retry calling the tool. Agent can go for an alternative path or a graceful feedback to the user. So the key insight, so if I talk about monitoring, so I can say that seeing is surviving, because if the agent knows where the problem is, it can survive the problem. So the key insight for monitoring in agentic AI system is seeing is surviving. So without monitoring, we will have a blind agent. So without monitoring, an agent is blind. So it might keep trying to confirm to user even if the call refund API step failed, leading to a catastrophic loss of trust. See, just imagine without monitoring, the agent will never get to know where the issue is, where exactly the issue is. Let us suppose call refund API it failed, but without monitoring, the agent will never get to know. And just imagine it will be a blunder because refund did not got initiated, and the agent will give a success message confirm to user that okay, refund done, and order refund successful, and there will be a loss of trust. The result will be like loss of trust. And we know that if the trust is gone, user will not use that agentic AI system. In agentic AI system, trust is very important. And without monitoring, we will have a blind agent. And with monitoring, we will be having a reliable system. Because with monitoring, we will be having a seeing agent. Agent will c- keep on looking at the progress. So for example, when the call refund API got triggered, the monitor check will see if the call refund API was success, it then only it will confirm to the user. Otherwise, if it is failed, it will go for a recovery strategy wherein it can retry, or it can go for a alternative API, or it can give a graceful feedback wherein it will clearly inform that there was some delay or some issue with the refund. I will try after some time. And with this, the trust will be maintained. So with monitoring, the trust is maintained. So monitoring transforms a fire and forget script into a reliable self-correcting system. Because of monitoring, our agentic AI system it will get to know exactly where the problem is, and it can recover, it can self correct, it can trigger a recovery strategy. And that's the importance of monitoring in agentic AI systems. Dynamic replanning. So now we will discuss dynamic replanning. So first let us understand what is replanning. So replanning is the dynamic correction of a goal's trajectory, adjusting the plan when something goes wrong or changes during the runtime. So that is what. So dynamic correction. Dynamic correction means when the system is running, then and there itself self correction, like the dynamic correction, like during the runtime of the system, adjusting the plan. That is what is the replanning is. So dynamic replanning. So it is the moment an agent realizes the current path is blocked and uses its reasoning capabilities to calculate a new route without giving up on the user. So that is what the dynamic replanning is. So the idea is that, let us suppose the agent, it made a plan, it decided a set of steps to be taken to achieve a goal. So it is now heading towards that action plan, and in one of the step something goes wrong. It is looking for a resource which is not available. Or something goes wrong in a particular step. Then instead of giving up, instead of throwing an error or halting the process, because of the orchestration, the agent will do the dynamic replanning wherein it will figure out a new route to achieve the goal. And that is what this dynamic replanning is. So you can think of replanning as the plan B or plan C or plan D capability. Like we know that we always have a plan B. Like if plan A goes wrong, we will go for the plan B. So replanning, you can think of it as a plan B. If planning is the architect's blueprint, so we know that planning is the blueprint. Like planning is like what needs to be done. It's like the blueprint. Then replanning is the site manager deciding what to do when they hit a pipe they did not know was there. So planning is a blueprint, and when we are acting on that blueprint, let us suppose we are building a structure on that blueprint, replanning is like a site manager which will take care of uncertainty or anything unusual happening in that blueprint. So that is what the replanning is. Now let us look at triggers. Like why exactly the pivot happens? What are the causes of the pivots? Like what is the need for dynamic replanning? Why there is a need for dynamic replanning? That we will discuss. So see, an agent needs to replan when reality does not match its internal model. So the idea is that an agent made a plan, and that plan contains some sequence of steps. Now a particular step is looking for a particular resource, the response of a particular tool, and that tool is not working or something wrong might happen. So here there is a need for an agent to replan. So an agent needs to replan when reality does not match its internal model. And what are the scenarios when reality does not match the internal model of an agent? Let us discuss those scenarios. So we can have tool failure. We can have tool failure. So an API returns an error or the website is down. So, so whenever there is a tool failure, in that scenario, the agent must decide, do I retry, keep on retrying, or do I find a different way? So that is where the replanning comes into the picture, because according to the plan, the agent has to execute a tool. And if that tool is not working, then the agent might have to replan, have to consider some alternate options. So whenever there is a tool failure, there is a need for dynamic replanning. Similarly, if an agent gets an unexpected output, like the agent expected a yes or no, but got a complex paragraph as output. So whenever an agent gets an unexpected output, in that scenario, the agent must now process the new information and adjust. It should replan, it should adjust because it got an unexpected output. Now it has to use that unexpected output and make it meaningful, make it useful. So there, the agent might need to replan. Whenever agent is dealing with missing data, there is a need for dynamic replanning. So let us suppose the agent all of a sudden it realizes it cannot book the flight because it does not have the user's passport number yet. So that is the missing information. So the agent is trying to book the flight, but the agent realizes it does not have the user's passport number. Then it has to dynamically replan. Now it has to add a new step in its plan, that is getting the passport number. So that is what dynamic replanning is. So whenever there is a missing data, there is a need for dynamic replanning. So in this particular scenario, the agent must pause the main plan to ask a clarifying question to get the passport number. So whenever we are dealing with missing data, there is a need for dynamic replanning by the agents. And also user changes intent. See, we know that in Agentic AI application, user behavior, it can change the we can see the shift in the user intent. The same user who wanted to fly to London, after 30 minutes his mind gets changed and the same user is now planning to fly to Paris. So that is what the change intent is. User changes intent. So mid process the user says, actually don't refund it, just give me store credit. So that is what the shift in the user intent. And whenever that happens, because whatever the plan was made, it was made based on the current intent. And if the intent gets changed, if the intent of the user is changed, the plan has to change, because now the old plan will become obsolete because of the change in the user intent. So whenever user changes intent, there is a need for dynamic replanning. So now it's very clear to us that in the scenario of tool failure, unexpected output, missing data, and user changes intent, we have to go for dynamic replanning, and orchestration plays a very important role in dynamic replanning. Now let us look at an example of dynamic replanning. So this is the example of dead end recovery. Let us understand it, what it is, the dead end recovery. So we start with an initial plan. So according to the initial plan, we have to identify the order, validate the order, call the refund API, and send confirmation to the user. Now let us suppose this was the initial plan. So step one was executed successfully, like the agent was able to identify the order. But in the step two, when the agent was trying to call the refund API, there was a conflict. So at step two, the system returns an error like item purchased 31 days ago, policy limit is 30 days. So at step two, there was an error that refund policy is applicable only for 30 days, but the item purchased was 31 days ago. So that refund is not eligible. So in this scenario, since there is a conflict occurred in the step two, there was an error, there is a need for dynamic replanning. So the agent will do the replan, the new plan. It will come up with a new plan, the replan. So instead of crashing, the agent generates a fresh sequence, the dynamic replanning, wherein it will explain, like tell the user they are 1 day outside the window. Then the agent will offer alternative. Check if store credit or item replacement is allowed for late returns. And then the agent will escalate. If the user is unhappy, it will create a ticket on behalf of the user for a human supervisor to override the policy. So in the runtime itself, there was an error in the step 2, and instead of crashing, the agent, it did the dynamic replanning, and here orchestration played the role. And this is the beauty of agentic AI systems. We call it the graceful recovery. We call the graceful recovery. So now let us discuss the key idea of dynamic replanning. So the key idea of dynamic replanning in agentic AI systems is resilience over rigidity. Because of dynamic replanning, our system will become very flexible. Our agentic AI system will become very flexible because any fault or any issue, instead of crashing, it will gracefully recover, it will replan, and it will lead towards the goal. So that is the key idea. Like if we talk about dynamic replanning, it is resilience over rigidity. So in the early days of AI, an error meant a crash. Like there was a need to halt the system and restart the system. But in the agentic era, an error is just a signal to replan. So in agentic AI applications, in agentic AI systems, if there is any error, instead of crashing, the system does the dynamic replanning and it recovers gracefully. So a good agent isn't one that never encounters an error. It's the one that handles the error so gracefully the user barely notices. So a good agent, it transforms a system failure into a problem solving session. So because of dynamic replanning, which is powered by the orchestration, agents can transform a system failure into a problem solving session. Incremental planning. Now we will discuss incremental planning. So first, let us look at the definition, like what is meant by incremental planning. What do we mean by incremental intelligence? So let us understand incremental intelligence first. So incremental planning, if I talk about planning one step at a time instead of entire workflow upfront, that is what is incremental planning is. Planning one step at a time, one by one. Step one, first you plan the step one, then step two, then step three, instead of the entire workflow upfront. So the idea is that, see, we have something called as batch planning. So in batch planning, what we do, we decide every move before starting. So before starting only, like we make the complete plan that, okay, this will be the step one, this will be the step two, this will be the step three, this will be the step four. We'll make a complete plan. But in incremental planning, we will not make the complete plan. Rather, we'll just plan the step one. And based on the response of the step one, whether the step one, based on the response of the step one, we'll decide the step two. We'll plan the step two. And based on the response of the step two, we will plan the step three. So one by one, we are planning. We are starting the system with just the step one. But in batch planning, we make the complete plan, like all the steps we planned before. We decide every move before starting. So now the difference between batch planning and increment planning is clear. So in incremental planning, we do the step-wise planning, which involves making a single decision, seeing what happens, and deciding what to do next. So first, it will just make a decision. It will make a small plan, like for step one. It will execute it, and based on the outcome of it, it will decide the next step. So incremental planning is step-wise planning. Step by step, we will plan one after the other. So incremental planning, it treats every action as a learning opportunity, not just a task to be checked off. Now let us understand why it's powerful. Like why is incremental planning so powerful in agentic AI systems? We are discussing the anti-fragile approach. We are discussing the anti-fragile approach. Let us see what is this anti-fragile approach is. So see, incremental planning, it handles uncertainty. Because see, the idea is that in incremental planning, we are not making the complete plan. Like we are not deciding all the steps. And because of that, incremental planning is very flexible because the response of the step one or the outcome of the step one will decide the step two. So incremental planning handles uncertainty. See, in the real world, you don't know always what's behind the next door. Because we know that the real world is very uncertain. We don't know what might happen next. So by only planning one step at a time, the agent does not waste energy preparing for scenarios that might never happen. What if in a particular step a tool is not at all giving a response? Then our plan will fail. So instead of wasting energy on preparing the entire plan, just let us plan the step one, and based on the outcome of the step one, let us plan the step two, step three, like that. So that is what incremental planning is, and hence incremental planning, it handles the uncertainty. Incremental planning, it also reduces the complexity. See, instead of solving a 10-step puzzle all at once, which is hard for large language model, and it can be prone to logic errors as well, the agent only has to solve one small piece at a time. So instead of solving a 10-step puzzle all at once, which can be hard for large language models and prone to logic errors, the agent only has to solve one small piece at a time. So incremental planning, it reduces the complexity. And incremental planning, it adapts in real time. Incremental planning, it adapts in real time. So it is making sense. See, the idea is that if step one reveals a surprise, like step one we get an uncertainty or we get an unexpected output or an unexpected error, like we get a surprise like password expired, the agent can address it immediately in step two because of incremental planning without having to throw away a massive pre-made plan. So any uncertainty, agent can handle it there itself because the step two will be based on the outcome of the step one. So, so if the outcome of the step one was a surprise, like the password got expired, step two can address that issue, and step two can be to prompt the user to reset the password. So that's the idea. So if step one reveals a surprise, the agent can address it immediately in step two without having to throw away a massive pre-made plan. So that is what with incremental planning, our agentic AI systems, it adapts in real time. It adapts in real time. Now we will discuss the flow, the OODA loop for AI. So now let us look at a OODA loop for AI, like the flow for incremental planning. So the flow, if we talk about it, is a continuous loop, and it is often referred to as hot action observation. Hot action observation. So how it works? So in incremental planning, first we decide the next step. So based on the outcome of the current step, we will decide the next step. So decide next step. So here, what happens is that the large language model, it looks at the goal and the current state of the system, like the response or the outcome of the current step, it will look at, and also the goal which needs to be accomplished. And it feeds the observation back into the prompt to LLM to determine the next logical move. So that is what deciding the next step is. So based on the outcome of the current step and also the goal which needs to be accomplished, the agent will decide the next step. So that is what decide the next step. And once the next step is decided, it will get executed. Execute the next step. So for execution, the agent may call a tool. So the next step will get executed. Then the agent will observe. like the outcomes of that step, the outcomes of the execution. So it reads the output. The agent will read the output, the observation, and then based on the outcome and also the goal to be achieved, it will decide the next step, and then it will execute it, and it will observe the output, and based on the output of that step and the goal to be achieved, it will decide the next step, and it will keep on doing it until the end goal is achieved. So that is what we call it, the thought, action, observation. So thought means make a plan, like decide the next step. Action means execute that step, and observation means observe the outcome and make use of the outcome and the goal to be achieved to once again thought to decide the next step, and we will keep on doing it until the end goal is achieved. So it is a feedback loop, it's a continuous loop, it will keep on running until the end goal is achieved. And this is the flow of incremental planning. This is how the incremental planning it works. So now let us look at the gold standard architectures. So incremental planning, it is used in some gold standard architectures like the React style agents and autonomous systems. So let us first understand the React style agents. So React style agents means the agents which reason and act. So incremental planning is used in React style agents like the reason plus act agents. So React style agents, they are the most famous framework. So it's a step-by-step process wherein the agent will first decide the next step, the thought, the next step to be taken. Then it will execute that step, the action, and it will observe the outcome of that step, and it will make use of that outcome along with the end goal to achieve, to think about the next step, to decide the next step, and it will once again execute it, and then observe the outcome, and it will make use of that outcome along with the end goal to achieve, to decide the next step, and it will keep on doing it. So that is what the incremental planning is. And here the agent is reasoning and acting. So first it is reasoning, means it is making a plan, like it is deciding the next step, and then it is acting on it, and based on the outcome of it, it will once again decide the next step, act on it, and it will keep on doing it. So it's an incremental planning, example of incremental planning. So we call it the gold standard architectures. Similarly, if we talk about autonomous systems like a self-driving car or a web agent. So in autonomous systems like a self-driving car or web agent, no full plan is made upfront. So they don't plan the entire drive or every click upfront. No full plan is made upfront. Very important one. Rather, autonomous systems, they react to the real world scenarios. So they react to the traffic light or page load in real time. And based on that, they will decide their next move. So it's like the game of chess. Based on the opponent move, I will decide my next move. So based on the real world scenario, we will decide our next step. So the agent will not decide everything upfront in autonomous systems. So now it's very clear that if we talk about incremental planning, so we have two gold standard architectures where incremental planning is used. So in React style agents like the reason plus act, and also in autonomous systems, incremental planning is used. Now let us look at the key insight of incremental planning. So incremental planning means thinking while acting. So incremental planning means we keep on thinking about the next step. So thinking while acting. So see, in traditional software, if we talk about the logic of the traditional software, the logic is if X then Y. Like we start, whenever we start the software based on the the logic is more of like conditional. If the value of X is true, then Y, else Z. So traditional software, it has a algorithm. Like we have been programming traditional softwares for decades, and what we do, we make a recipe and a full algorithm, and we, that program is given an input, and based on the algorithm the input will get processed. So traditional software, they follow a recipe, they follow a fixed path. Traditional softwares, they follow a recipe, they follow a fixed path. But if we talk about incremental planning, the logic in incremental planning, here we don't have a fixed plan, we don't plan everything upfront, we don't have a full-fledged algorithm in incremental planning. In incremental planning, what is happening is we start with the current state and the end goal to achieve, and based on the current state and the goal which needs to be accomplished, we will decide the next step. So I have done X, now what makes sense, what should I do? Should I go for action A, action B, or action C? So that is what incremental planning is. Based on the outcome of the current step and the end goal to be achieved, the next step is decided. So in incremental planning, the entire plan is not made upfront. So in the analogy is, in incremental planning, it is like tasting the soup as they cook. Like as we cook the soup, we keep on tasting it also, whether to check whether the soup is in the right direction or not, and making changes where and where needed, like adding seasoning as needed. Now this shift in approach makes agent more resilient, because now they become environment aware, because now with this incremental planning our agent will become very flexible, they can handle uncertainty, they can adapt real world situations, and they will become environment aware, and hence they will become more resilient. They are not just following a recipe, they are tasting the soup as they cook and adding seasoning as needed. So that is what incremental planning is. Supervising tool execution. Now let us discuss supervising tool execution. So first let us start with the problem, the reliability gap, the problem of reliability gap. Let us understand what it is, the reliability gap. See, the idea is that tools are not always reliable, because we know that we might use some third party tools, some third party APIs, they might not be available, they might go down, tools might generate some error. So tools are not always reliable, and that is what the reliability gap is. Because if we talk about tools like the APIs, the databases, the scripts, they're fragile, they can break. So if they get brittle inputs, they may break. Because let us suppose a tool is expecting an integer, but the LLM sends a string. In that scenario, the tool will break. So brittle inputs can lead to the breaking of the tool, like the tool will give error. Unstable connections. So we might get something like API timeout, or return, or the tool may return rate limit exceeded. So unstable connections can lead to the breaking of tools. And hallucinations. So an LLM might invent a tool parameter that does not actually exist. Like a tool, an LLM is trying to send a tool parameter that the tool does not understand. The tool, so that's the idea. So the LLM might hallucinate, wherein it might drift away from the tool specification. So according to the tool specification, the tool can receive only 3 parameters, but LLM is trying to send 5 parameters. In that scenario, we will get a tool error. The tool will break. So now the idea is very clear that the tools are not always reliable. The tools can break. The tools are fragile. Like if we give brittle inputs, or because of unstable connections or the hallucinations, the tools, they may break. The tools are not always reliable. So responsibilities, the inspector duties. Since the tools are not reliable, the tools are fragile, the tools can break, tool orchestration comes into the picture. So in the word of AI agents, tool orchestration acts as the middle manager or the quality control inspector. So the tool orchestration ensures that the raw power of an LLM does not result in a broken systems or incorrect data. So now we are getting an idea of tool orchestration layer, because with tools are fragile, tools can break. There is a reliability gap is there, like we cannot rely on tools. And because of that, there is a need for tool orchestration layer. So the idea is that the large language model, it will generate some commands for the tools, but this tool orchestration layer, it will act like a quality control inspector, and it will ensure that no broken systems or incorrect data. And this tool orchestration layer, it fills the reliability gap. It fills the reliability gap. So instead of directly connecting the large language model with the tools, the idea is that now we will have a tool orchestration layer in the middle. So both the tools and the large language model, they will be interacting with the tool orchestration layer, or the large language model will be interacting with the tools, and tools will be interacting with the large language model via the tool orchestration layer. So that is what the tool orchestration layer is about. To solve the reliability gap, the tool orchestration layer, it takes on four critical tasks. So let us understand that. So the first critical task is validate inputs. So before calling the tools, the tool orchestration layer will validate the inputs, whether the inputs are in the correct form or not. Because we already saw that brittle inputs can break the tools. So tool orchestration layer, they will validate the inputs. They will check the format of the input. For example, like, does the order ID follow the correct format? Similarly, if I talk about tool orchestration layer, it checks the outputs as well. The output format, the response, it will check for that. Like once the tool finishes, the system inspects the result. Did it return the transaction number? For example, it can check whether the response was a transaction number or not. Tool orchestration layer, it also handles the tool errors. Like it will catch exception. So let us suppose a tool generated an error. So if the tool crashes, the orchestrator catches the exception, so the whole agent does not die. So the tool orchestration layer, it will catch the exception, and it will not let the agent to collapse. And the tool orchestration layer, it also carries out a very critical task of retry or fallback. So the idea is that, let us suppose if a tool gets failed, so the tool orchestration layer will decide whether to retry calling the tool or fallback, like bring human in the loop, or ask the user, or convey the message to the user. So retry or fallback. So the tool orchestration layer will decide, like if the tool fails, whether to try again or use an alternative. So now the importance of tool orchestration layer is very clear to us, that the large language model, they will interact with the tools via the tool orchestration layer. Tool orchestration layer, it will ensure that it will perform four critical tasks, like it will validate the inputs, it will check the outputs of the tools, it will handle errors, it will catch the exceptions, and if the tool fails, the tool orchestration layer will decide whether to try again or use alternatives. So that is what the tool orchestration layer is about. It is like the quality control inspector, the middle manager. Now let us look at an example, the refund supervisor. Let us look at an example of the refund supervisor. So if the agent wants to issue refund on a particular order ID and an amount, so we have an agent, it will call a tool called issue refund, and the agent is passing two parameters, the order ID and the amount. And now This instruction is not sent directly to the tool, rather it is sent to the tool orchestration layer, and we also call it the supervisor layer. The tool orchestration layer is also called as the supervisor layer. Now this supervisor layer, the tool orchestration layer, what it will do is it will first do the pre-check. So it will check like the amount which is given, like the $50. Is it more than the original purchase price? If yes, stop execution, because here the user is expecting a refund amount. If the refund amount is more than the purchase price, then it means user is trying to scam, and we will stop there itself. And if the refund amount is equal to or less than the purchase price, then we will move ahead. Otherwise, we will understand it's a scam and we will stop there itself. So the tool supervisor layer, the tool orchestration layer, it will decide whether to stop or proceed after the pre-check. Then once the pre-check is done, it will execute. So the tool orchestration layer will call the tool. And once the tool is executed, it will generate the response. The tool will generate the response. That response, we will not directly pass it to the LLM. Rather, we will send that response first to the supervisor layer, tool supervisor layer, tool orchestration layer. So the tool orchestration layer will check the response. We call it the post check. So let us suppose the API returned status 200. Now let's verify the refund ID is logged in our internal database. So whatever response it got, it will just cross check it. And then if the response was okay, it will send it to the large language model. Otherwise, it will stop there itself. Or it will send an appropriate message to the large language model so that the large language model can further handle the user interaction. So this is how tool supervisor layer works, the tool orchestration works. So the tool orchestration layer acts like a safety layer which prevents the agent chaos. The tool orchestration layer is the safety layer which prevents the agent chaos. So tool orchestration layer, it prevents the incorrect usage, because we know that the tool orchestration layer, it will check the input, the output, and hence it will prevent the incorrect usage. It stops the agent from guessing how to use the tool. It Because the tool orchestration layer, it will block the incorrect inputs, and hence it will prevent the agent chaos. Similarly, the tool orchestration layer, it avoids the cascading failures. So let us see how it avoids the cascading failure. So let us suppose if step A, the tool fails. So in step A, there was a tool action and the tool got failed. The tool orchestration layer, the tool supervisor, it prevents step B from firing. Because now what is happening is that we have a tool orchestration layer which is acting like the middle manager. So if a tool got failed, the tool orchestration layer will get to know about it, and step B will never be called. Step B will be blocked. So the tool orchestration layer, it prevents embarrassing "I have refunded you" email when refund actually failed. So tool orchestration layer, it ensures reliability and prevents embarrassments. Now let us look at the key idea, tool governance. So see the idea, the key idea of tool orchestration layer is the tool governance. So orchestration is basically the tool governance layer. Tool orchestration layer is the tool governance layer. It treats tools not as magic buttons, but as regulated processes. It provides a sandbox where the agent can interact with the real world safely, ensuring that every action is verified, logged, and corrected if necessary. So the idea is very clear that agent will not directly interact with the real world, the tools, because the tools, are the part of the real world, like the database, the API, the resources. So the agent is not directly interacting with the real world. Rather, there is a middle layer. We also can also call it the safety layer, the tool governance layer, the tool orchestration layer, which acts like a sandbox, a safe zone. So this layer will validate the agent request. So agent will request first send the request to this tool orchestration layer, which will do the verification. And then if everything is correct, it will execute. And whatever response it got, first it will be given to this tool orchestration layer, and then it will be sent to the agent. So agent will be interacting with the real world tools via this tool orchestration layer, which will act like a sandbox, a safe zone, which will ensure safe interaction, which will ensure that every action is verified, it is logged, and it is corrected. So that's the idea. Adapting to environment changes. So now we will discuss adapting to environment changes. So if we talk about environment, environment is basically the agent's reality. Environment is where the agent will operate. So if we talk about environment, it includes the agent's reality. So let us first understand environment. So an agent's environment is the sum of everything it can perceive or influence. So if we talk about agent's environment, it includes the APIs, application programming interfaces, APIs. So the APIs, we know that it is the bridge to other softwares. Like through APIs, we can connect with other systems or other softwares. So like we have APIs of Stripe, Slack, Jira. So these are like APIs. Now APIs, they have their own rules and uptime. So agents environment, if we talk about, it includes APIs, the bridge to other software, and APIs of other system, it includes their own rules and uptime. Similarly, we have databases like agents environment, it includes databases because we are discussing agents environment. So it includes databases. So databases, we know it represents the source of truth. So data here can be updated by other users or systems while the agent is working. So concurrently, many users and systems can access database. So data in a database can be updated by other users or systems while the agent is working. So agent's environment, it include databases, the source of truth. If we talk about agent's environment, it also includes the user behavior. Agent's environment also includes the user behavior. And the user behavior is the most unpredictable element in the agent's environment. Because APIs, databases, external systems, they show predictable behavior. But user behavior is something which is the most unpredictable element in the agent's environment. See, humans are non-linear, often providing partial information or correcting themselves. So that's why human behavior or the user behavior is the most unpredictable element in the agent's environment. But user behavior is a part of agent's environment because users will be using the agent systems, agentic AI systems. Users will be interacting with the agentic AI systems. And user behavior is the most unpredictable element in the agent's environment. Similarly, we have like external systems. So if we talk about agents environment, it also include external systems. And if I talk about external systems, I'm talking about web pages, file systems, sensors, or some other external systems that provide the real world context. So external systems are also the part of agent's environment, like the web pages, file system, sensors, or any other external system that provide the real world context. So this is how agent's environment it looks like. So agent's environment, if we talk about, it includes the APIs, the databases, the user behavior, and the external systems. And user behavior is the most unpredictable element in agent's environment. So now let us look at types of changes. So the if we talk about agent's environment, the agent's environment is uncertain. Agentic AI systems they operate in uncertain environments which are prone to changes. And now let us look at the type of changes which agentic AI systems may encounter. So now we are discussing the type of changes, type of environment changes in agentic AI systems, the chaos factors. So because the agentic AI systems environment, they are not non-static, they are uncertain, they are prone to changes, the agent must handle three types of disruption. So the three very important types of changes we are discussing. The first one is the API downtime or the latency. Now we know that API is a part of agent's environment, and there may be scenarios where the API may not be available. The API might be down. So a tool that worked 5 minutes ago might be down for maintenance now. So a tool which is working very fine, suddenly it's not working, something is wrong with it. So that is what API downtime is. So a tool which worked 5 minutes ago, now it is down for maintenance. So agentic AI systems, if we talk about, they are operating in an uncertain environment, and that uncertain environment it can encounter some changes, and API downtime is a very common environmental change which we can see. And how to deal with it, how to deal with API downtimes: retry mechanism, fallback mechanism, timeout handling. So the idea is that if a tool is down, we should keep on retrying, like after few seconds, or we call it like exponential. Like first we will hit the retry request after every 1 second, then we will make it 2 second and 4 second, like that we will do. So that is the retry mechanism or fallback mechanism, wherein we can go for any alternate path. Like a tool is down, we can go for any alternate tool. Timeout handling. So these are like some of the way to deal with API downtime changes. Data inconsistency. Now we are discussing the types of environment changes in agent systems. So data inconsistency is also a type of environment change. So agentic AI systems, they are prone to data inconsistency. So the idea is that the agent, it reads an order as shipped. The agent, it reads an order as shipped. But by the time it tries to cancel the order, the status has changed to delivered because of the time lag. So there is a conflict. So the idea is that while the agent read the order as shipped, in reality the order, its status got changed to delivered. So in reality the order got delivered, but the agent is still reading it to be shipped because of some data inconsistencies, some time lag. Because in the real time, the status of the order, it became delivered, but the agent is still reading it to be shipped. So it's a very big data inconsistency. And just imagine the blunder, like, because here the agent is reading a wrong status, and that can be a very big blunder for the agentic AI system. So that is what the data inconsistency is. So the state changes between read and act. So by the time the agent is trying to read the status might have updated. So the agent ends up reading something about the status, but in reality, the status is something very different. And this is a data inconsistency problem, which can be very dangerous in agentic AI systems. So agentic AI systems, if we talk about the agent's environment, they are prone to data inconsistency. And now the big question, how to handle data inconsistency? So revalidate. So the idea is that whenever the agent is reading the status, it should revalidate. It should cross check from the backend of the system. It should revalidate. And we should use optimistic locking so that the read, so there should be a perfect synchronization between the read and the write. So the idea is that if we are updating an information, we are updating the status, the read should be locked. To avoid the conflict, to avoid the data inconsistency, one of the ways is that while we are updating the status, we should lock the read. And once the status have been updated successfully, then we should release the lock on the read and we should read the data. So this is the idea, data inconsistency. So now it's very clear that in agentic, like in agents environment, data inconsistency is a very big and like very critical type of change. Now the third type of change in agent AI system is the user pivot. See, the idea is that we already saw that in agents environment, users, the humans, they will be using the system, they will be using the agentic AI system, and user behavior is the most unpredictable element in the agent's environment, and hence agent's environment is prone to this unpredictable user behavior, and that is what user pivot is. So the idea is that the user realizes a mistake or changes their mind in the middle of a multi-step process. So earlier they decided something and the agent is working in accomplishing that goal, and all of a sudden in the middle, there is a shift, like the user is changing his mind, or there is a shift in the intent of the user. So the idea is like the agent, it is working on a multi step process. So step 1, step 2 completed, and all of a sudden there is a change of mind in the user, and because of that this path is blocked, and because of that change in mind, now the agentic AI system, the agents, they have to orchestrate the new plan and a new multi-step process. So that is what user pivot is. So the idea is that the user realizes mistake or changes goal mid process. So that is what the user pivot is. Now how to deal with it, how to handle it? So we have something called as undo redo. So instead of completely changing like all the steps, there should be a like concept of undo and redo. So the idea is that let us suppose user made a mistake, there should be something to undo, step back or redo, and flexible workflows. So the idea of flexible workflows is the incremental planning. Rather than planning all the steps initially, we should plan step by step. So the idea is that first we should just plan the step 1, and the outcome of the step 1 should decide the step 2. The outcome of the step 2 should decide the step 3. So that is what the flexible workflow is, incremental planning. So with this incremental planning, we can take care of user pivot. Let us suppose after step 2, the user is changing the mind. Now the step 3 we haven't planned yet. So the good thing is that now we are flexible. Step 3 will take care of the shift in the user intent. So that's the flexible workflows we are talking about. So now it's very clear to us that, okay, agents environment, they're prone to changes. And what are the types of changes which we can see in agents environment, the chaos factors? So for the first one is the API downtime, wherein the tools, they may all of a sudden they may not work at all. They are down for maintenance. There can be a problem of data inconsistency and the user pivot, because we already saw that user behavior is the most unpredictable element in the agent's environment. All of a sudden, user can change his or her mind, and hence the the agent, the orchestration, if we talk about the agent, it should support flexible workflows, incremental planning. Now let us look at an example, the mid-task pivot. So now we are looking at an example of adapting to environment changes. So there is an environment change wherein the user is changing his mind, and let us see how our agentic AI system will adapt to environment changes with orchestration. So orchestration enables the agentic AI systems to adapt to environment changes. So let us first discuss the scenario. The scenario is the agent is halfway through a complex refund workflow. So the scenario is of a complex refund workflow, and the agent is halfway through a complex refund workflow. So if I talk about the internal state, agent has validated the order and is literally holding the pen to sign the refund API call. So the current state of agent, if we talk about the, so the idea is that the agent has already validated the order, because if we talk about refund workflow, so the idea is that first I have to validate the order, whether the order is valid or not. Then I have to check whether the order is eligible for refund or not, because there might be some refund policy, some 15 days replacement or 30 days. So whether the order is still in that window, is it eligible for refund? So that is what validating order means. And agent has already validated the order, and agent is just about to call the refund API. So agent is just about to call the refund API. Now suddenly there is a change, and let us understand the change. So the user gives a prompt to the agent. The user sends a message, actually don't refund it, I will keep it, but can you change the shipping address for my next order? So all of a sudden the user changed his mind, and user is telling that don't refund the order, the user will keep it, just change the shipping address for the next order. So all, because initially we started with the refund workflow, and in the middle, when the agent is about to call the refund API, the user just gave a new prompt, and there was a mid task pivot. There is a change in mind of the user. Now the user don't want refund, rather the user wants to change the shipping address for the next order. And now let us see how agent will adapt to this environment change using orchestration. So let us look at the agentic response. Let us look at the agentic response, how the user will respond. So the first thing the agent will do is interrupt. The first thing the user will do is interrupt. Interrupt means whatever the agent is doing, it will just stop it. So it will interrupt. So it will kill the refund process to prevent the accidental transfer. It will immediately kill the refund process to prevent accidental transfer. Then the second step the agent will do is acknowledge. And in acknowledge, the agent will confirm to the user that refund workflow was aborted. So confirm to the user that the refund has been aborted, and then the agent will reevaluate. Like now it will make a new goal. It will make a new plan for the new goal. So it will re-evaluate. So look at the new goal. That is the change the shipping address for the next order. And after re-evaluating, looking at the new goal, the agent will replan and execute that plan. So it will replan and execute that plan. So start address change workflow. So this is how Agentic AI system, they adapt to environment changes through orchestration. So here orchestration is the key. So the idea is that whenever there is a mid-task pivot, the agent will first interrupt, kill the current workflow. Then the agent will acknowledge, wherein the agent will confirm that the current workflow was aborted. Then the agent will reevaluate the new goal and it will replan and execute the workflow for the new goal. So this is how agents, they adapt to environment changes via orchestration. Here orchestration is the key. So the key insight here is the non-static operations. Non-static operations. So now let us understand what do we mean by non-static operations. So see, in traditional programming, which we have been doing for decades, we assume the environment is static. We assume the environment is certain, deterministic, it is static. So in traditional programming, we always assume the environment to be static. So if I click X, Y always happens. So the idea is that in traditional programming, we assume that, okay, if I click on something called as X, since the environment is static, it is assumed to be static always. Same output, like Y I will get always. Like if I click on the save button, it will save the file. It is not like it will delete the file. And that is what we have been doing. Like all the softwares we use, we know that, okay, if I click this button, this will happen. It never happens like if I click this button, some all of a sudden something else happens. This we haven't seen. We have been using softwares, we have been developing softwares using traditional programming, and wherein this static approach is perfectly fine. It fits also because we haven't seen a scenario wherein we click on a button and something else is happening. Whatever the button is intended for, only that result we will get. So that is what we have seen in traditional programming, and it makes sense also. But if we talk about agents, they operate in non-static environments. So agents we cannot assume this static approach. Agents, they operate in non-static environment. So in agentic era, like when we are dealing with agentic AI systems, we have to consider the dynamic approach. And in this dynamic approach, orchestration will play the role. Now, first, let us understand the dynamic approach. Then you will get to know the importance of orchestration as well. So the idea is that now the agent is working in a or operating in a dynamic environment. So dynamic environment means uncertain environment which is prone to changes. So the idea is that now the agent, it continuously observes the dynamic environment, and based on the changes in the dynamic environment, it is since it is observing, there is a situational awareness is there. So the agent's greatest strength is not just following instructions, it's situational awareness. So in agentic AI systems, the agents, they have something called as situational awareness, and that is their core strength. Like agents, they keep on observing the environment, and any changes in the environment, they identify it and they adapt and act accordingly. So adapting to environment changes is like the core strength of agentic AI systems, of AI agents, and that is what the situational awareness is. So in agentic era, we assume the environment is dynamic, and AI agents, they have something called a situational awareness, which is their core strength, because of which they adapt. Like any change in the environment, they adapt and they act. So that's the idea. So a truly smart agent spends as much time observing the environment as it does acting on it. So, a truly smart agent is the one which spends as much time observing the environment as it does acting on the environment. So, this is what adapting to environment changes. So, agentic AI systems, they operate in dynamic environment. So, hence there is a concept of non-static operations. And AI agents, they have something called a situational awareness. So they spend as much time observing the environment as acting on the environment. Ensuring step alignment toward goals. So now we will discuss ensuring step alignment toward goals. See, the core problem in AI agents is the lost agent. It means drifting away from the goal. The lost agent means the agent, it drifts away from the goal. That's the core problem of AI agents, goal drift. So without strict alignment, large language model based agents, they often fall into three traps. So the first trap is the goal drift. The second trap is the irrelevant actions. And the third trap is the infinite loops. So if we talk about goal drift, the agent gets distracted by a secondary detail like a side comment from the user and forgets the original mission. So that is what goal drift. So goal drift is that the agent all of a sudden it starts focusing more on the side comment or the secondary detail, and automatically because of that it is drifting away from the original mission. It is forgetting the original mission, and that is what the goal drift is. So in goal drift, the agent, it gets distracted by the side comment and forgets the original mission. So that is what the goal drift is. If I talk about irrelevant actions, so the agent uses a tool just because it is available and not because it is needed. So that is what irrelevant actions mean. So the idea is that the agent is using a tool because it is available, because the tool is available, not because that tool is needed. For example, searching for weather data during a refund. Because see, searching for weather data has nothing to do with refund order. But since weather data, like searching for weather data tool is available, it is just making use of the available tool despite that is not needed. And that is what irrelevant actions means. And it happens because when the large language model, it hallucinates means it gets confused. When the large language model, it gets confused, it may call some tools which might not be relevant for a particular task, and hence we end up having irrelevant actions. And the example of it is the AI agent, it is searching for weather data during a order refund workflow. And the third trap is the infinite loops. So here the agent, it tries the same failing step over and over. So it tries the same failing step repeatedly. And because of that, it is consuming tokens and times. So that is what infinite loop is, wherein the agent tries same failing step repeatedly with a hope for a different result. But with this uh, repeating the same failing step over and over, the agent, the AI agent, it is unnecessarily consuming tokens and time. And that is what the infinite loop trap is. So now it's very clear that if we talk about AI agents, they can get lost. That is what the core problem is, the lost agent. And if I talk about the lost agent is the one which has drifted away from the goal, which is performing irrelevant actions, and which is stuck in an infinite loop, wherein it is making the same mistakes again and again. unnecessarily consuming tokens and time. Now, what is the solution? How to deal with the lost agent? So now let us discuss the solution. So the solution is the continuous alignment. So here continuous alignment is the key. So the idea is instead of fire and forget, the orchestration layer, it acts as a supervisor that constantly asks, are we there yet? And are we still on the right road? So the idea is very clear that here orchestration plays a very important role. So if we talk about ensuring step alignment towards goal, the solution is continuous alignment. In continuous alignment, orchestration plays the role wherein the orchestration layer, it acts like a supervisor that constantly keeps on asking, have we reached the goal? If we haven't reached the goal, then are we still on the right road? So this is the main crux of the orchestration layer, because constantly it keeps on checking whether the end goal is reached. If it is not reached, are we heading towards the end goal? Are we still on the right road? So here this orchestration layer is acting like the supervisor, and this is enabling the continuous alignment. So we can get continuous alignment because of orchestration layer, which is acting as a supervisor that constantly keeps on checking whether the goal is reached, and if not, are we heading towards the goal? Are we still on the right road? So continuous alignment, it forces agent to justify next move against original goal. So it forces the agent to justify its next move against the original goal. That is what continuous alignment means. Means now the orchestration layer, it knows that this is our current state and we have to reach a point. Then it will help in deciding the next plan or the next step. So that is what continuous alignment is. In continuous alignment, the next step will be aligned towards the end goal. So orchestration layer, the supervisor, it forces the agent to justify next move against the original goal. So now let us discuss the questions to ask, the internal monologue. So the orchestration layer, it acts like a supervisor, and constantly it keeps on asking the AI agents certain questions for continuous alignment to ensure that the AI agent is heading towards his goal and not drifting away from it. And now let us discuss what are these questions which the orchestration layer, it asks the AI agents. Let us discuss the internal monologue. So the first question is about, is this step helping the goal? Like, is the current step, it, it is helping the goal? So this is about relevance. The first question is about relevance. Like, is this step relevant? Is this step will take us to the goal? Second important question which the orchestration layer asks AI agent is this action necessary? We are talking about efficiency, because if some actions we can eliminate, we can make our system more efficient, because unless we can get rid of consuming unnecessary resources. So is this action necessary is a very important question, and that talks about the efficiency. Now the next question is, are we progressing? Are we progressing towards the goal? So this is a question which is asked by the orchestration layer, and this question is asking about the velocity. And the next question asked by the orchestration layer to AI agents in order to ensure continuous alignment with the goal is, have we already tried this? Like whatever the current step is, have we already tried it? So we are doing a redundancy check, because if we have already tried it, then no point of trying it once again. And with this, we are avoiding infinite loop, because infinite loops, they are a trap. They can drift away AI agents from their goal. So redundancy check. So see, Relevance is about strictly aligning with the goal, avoiding from goal drift. Efficiency and velocity is about making use of the right tools, like whatever action we will be performing, whatever tools we will be calling, is it necessary? Can we avoid it? And the orchestration layer will be asking questions to the AI agents about the redundancy check. So these are like questions which the orchestration layer it asks AI agents to ensure that the AI agent is strictly aligned towards the goal, continuous alignment. Now let us look at an example to understand it more clearly. So the example is the refund distraction. Let us understand this example of the refund distraction. So the goal is to refund a damaged shirt. So there is a damaged shirt and we have to refund it. Now let us understand the drift. So the drift is the agent sees the shirt is blue and starts recommending blue pants to the user. So that's the drift. So the idea is that instead of starting the refund workflow, the agent got drifted from its goal and it started recommending blue pants to the user. So that is the goal drift we are talking about. And the correction. Now let us discuss the correction, like how we can come out of it. How the AI agent get back to its original goal of refunding the damaged shirt. So the alignment layer, so the orchestration layer, which is acting like the supervisor, it intercepts this because we know that the orchestration layer constantly it is keeping an eye on the AI agent, and it will see that instead of initiating the refund workflow, the agent is recommending blue pants because constantly the orchestration layer is checking and it will get to know. So it sees the orchestration layer sees the refund is still incomplete and upselling is not a part of the mission. It kills the bad step and redirects the agent to validate the order. And here is where the orchestration plays a role. So now it's very clear that with this example, we got a very good understanding that how exactly the orchestration layer it ensures alignment towards the goal. It ensures that AI agents they are strictly aligned towards achieving their goals. Now let us look at some techniques of continuous goal alignment, keeping the rails on. Like some of the techniques like how we can ensure that the AI agents will be strictly aligned towards their goals. So the first very important technique is making use of goal tracking variables. So we will make use of goal tracking variables. So we will make use of a status board, goal tracking variables. So this status board, it will be a persistent, means it will be like a permanent storage, a persistent status board that explicitly lists what is done and what is still left. So that is what the goal tracking is. So now we are discussing the techniques, like how we can ensure that AI agents they are perfectly aligned towards their goal. So we have to maintain a status board wherein we have to keep track of what is done and what is left. Like for example, is item identified? Yes, it is. Is refund sent? No, it is not yet. So we have to make use of the status board. The second is reward functions in reinforcement learning, or self critic also we can call it. So reward functions or the self critic. Now let us understand what it is, reward functions or the self critic. So the idea is that the agent generates a response. The agent will generate a response. Then a second critic prompt evaluates it. So agent will generate a response. We will evaluate that response. So there will be a critic prompt that will evaluate it. Like, does this response move us closer to the refund? And this evaluation is taken care by the orchestration layer. So what orchestration layer is doing is that whatever the agent response it is getting, orchestration layer is acting like a supervisor wherein it is sending that response with some critic prompt to a LLM to check the relevancy, efficiency of the agent response, to evaluate the agent response. Like with this response, shall we move closer to our goal? And if yes, then we will proceed with that response. Otherwise, we will just discard that response and ask the agent to give a new response. So that is what self-critic is. And with this, we will ensure that the agent is strictly aligned towards the goal. Because let us suppose there is an agent response and the orchestration layer, it is evaluating it. And if it feels like that response will not take us towards our goal, there itself we can eliminate it. So we can avoid our Agentic AI system from getting drifted away from its goal. So here orchestration layer is playing a role. Now the third important technique which we can adopt is the constraint based planning. Constraint based planning. So the idea is that hard rules. So constraint based plannings are basically the hard rules, like never call API 3 times, like more than 3 times. Never ask user for same information twice. So with this constraint based planning with some fixed hard rules, we can avoid infinite loops. We can avoid calling irrelevant tools. So that is what constraint based planning. And this has also been taken care by the orchestration layer, because in the status board, we are keeping track of the, like what the agent AI system did and what it is supposed to do. And when the orchestration layer will refer to the status board, it will get to know that, okay, our agent AI system, it called this API more than 3 times and still the API is down. Then it will not call it again. Our agent AI system has already asked the user about the information because that is there in the status board. So now our agent AI system will not ask for the same information twice. So this is like we discussed some very interesting techniques which will ensure that our AI agentic, like AI agents, they are strictly aligned towards the goals. So we have to keep track of like goal tracking variables. We have to maintain a status board listing what is been done, what is been still pending. We should make use of reward functions, the self-critic. So the idea is that the orchestration layer, it will evaluate the agent's response, like it will send the agent response with the critic prompt to a large language model. The agent's response will be evaluated, and based on it, the orchestration layer will decide whether to proceed with the response or tell the agent to rewrite. And in this way, we can avoid our AI agents from getting distracted from the goal or getting drifted from the goal. And constraint based planning, some, like we make use of some hard rules, and the orchestration layer, it constantly checks the status board and looks at the rules. So that is what constraint based planning is. Now let us look at a key insight. So see, orchestration, it ensures direction, not just action. So if we talk about orchestration, orchestration is not just about planning, like generating a sequence of steps. Orchestration is not just about that. Orchestration is also about ensuring the direction. Orchestration ensures that AI agent is aligned towards the goals, and AI agents, they are not drifted away from the goals. So orchestration ensures direction and not just actions. So the idea is that an agent can call 20 tools and generate 1000 words. Like an AI agent, it can call 20 tools, it can generate 1000 words. But if the refund isn't processed, it has failed. So the idea is that we are interested in processing the refund, and in that the agent can get drifted away. It can all or not get drifted away also, like to accomplish the task of refund. It might call 20 tools, it might generate thousands of words, but if it is still not able to process the refund, if it is not still able to accomplish the goal, then we call the AI agent is failed. Orchestration will ensure, so here orchestration is the key. Orchestration ensures that every token spent and every tool called is a purposeful step toward the final state. So orchestration, it constantly keeps on a check, and it ensures that every tool called or every step taken is purposeful, and it will lead towards the final goal, the refund process. So orchestration layer, it ensures relevancy, it ensures efficiency, it ensures velocity, it ensures redundancy check. Why orchestration is the backbone of agent systems? So now we will discuss why orchestration is the backbone of agent systems. See, without orchestration, our AI agent will be a dormant agent. So without orchestration, we will have the dormant agent. So without an orchestration, you have a pile of high-tech components, high-tech tools that can't talk to each other. So without orchestration, there will be tools. Tools exist, but are unused. So without orchestration, tools exist, but are unused. So like there will be a toolbox, but no hands. The LLM might know a refund API exists, but it does not know when and how to call it. So without orchestration, there will be no proper hands. There will be a toolbox will be there, but the large language model will know that there is a toolbox exists. It knows what tools are available, but it does not know when to call those tools and how to call those tools. So tool exists but are unused. Without orchestration, memory exists but not leveraged. So see, without orchestration, memory do exist, but it is not at all leveraged. So the agent has a database of user history, but the agent reads every message like it is meeting a stranger for the first time. So without orchestration, memory do exist, but it is not leveraged. And without orchestration, planning exists, but not executed. So the AI might say, I should refund this, but it never actually sends the command to the system. So without orchestration, the agentic AI system, the large language model, it knows what to do. But without coordination, like let us suppose multiple agents are there. So orchestration is the key, because without orchestration, planning do exist but not get executed. So now it's very clear that if we talk about agentic AI system in itself is a complete system with so many high-tech components. Like we have the large language models, we have memory, we have tools. So agentic AI system contains lots of high-tech components. Without orchestration, it will be dormant, because those high-tech components will not be able to talk to each other. There will be no coordination. So that's why without orchestration, tools exist, memory exists, planning exists, but they are not leveraged properly. So our agentic AI system will be just a dormant system. But with orchestration, our agentic AI system will become the synergetic agent. Our AI agent will become the synergetic agent. So with orchestration, we will have synergetic agent. So there will be a synergy. So we know that our agentic AI system contains lots of high-tech components. It contains large language models. It contains memory. It contains tools. With orchestration, these components will be able to talk to each other, coordinate with each other. and hence there will be a synergy and we will have synergetic agents. So orchestration creates emergent intelligence. Orchestration creates emergent intelligence. And what is this emergent intelligence? The whole becomes smarter than the sum of its parts. So the whole becomes smarter than the sum of its parts. That is what the emergent intelligence is. So with orchestration, everything works together. So with orchestration, everything works together. So memory informs the plan triggers the tool, and the tool they updates the memory. So with orchestration, everything works together. So there is a sync between the memory, the plan, the tools. So memory will inform the plan will trigger the tools, and tools will update the memory. So with orchestration, the system becomes intelligent. With orchestration, the system becomes intelligent. So the system does not just chat, but it reasons through obstacles. So with orchestration, the system becomes intelligent. The system not just chat, but it reasons through obstacles. And with orchestration, complex task, it becomes solvable. Complex task, it become solvable. Like long running processes can be managed with orchestration, because the orchestration tracks the state over time. Because if we talk about orchestration, the orchestrator, what it does is it tracks the state over time. It constantly keeps on looking at the system whether it is heading towards its goal or not. So it tracks the state over time, and because of that, complex task we can break it into multi-step process, and orchestrator can take care. It orchestration layer, it acts like a supervisor. It monitors each and every step, and based on that, it can also go for incremental planning, wherein the outcome of the current step will decide the next step to be taken. So complex tasks become solvable. So now it is very clear that with orchestration, we have synergetic agent. Orchestration creates emergent intelligence wherein the whole becomes smarter than the sum of the parts. With orchestration, everything starts working together, like the memory, the plan, the tool. There is a sync between them. Memory informs the plan triggers the tool updates the memory. With orchestration, systems like our agentic AI system will become more intelligent, and complex task it becomes solvable. Now let us look at the architecture view, the interactive flow, or we also call it the instruction pipeline. Like with orchestration, how the instruction pipeline works in agentic AI systems. So the idea is that we start with the user input. We start with the user request, which is the input. So it is the raw request. For example, fix my billing error. It's a user request. So the user request, it is sent to the orchestrator. The orchestrator, what it will do, it will analyze the intent of the user request, and then it will send it to a particular LLM, because we can have a multi-agent system as well, wherein we can have multiple LLMs. So based on the user request, it will analyze the intent, and based on the intent, it will call a particular LLM. It will send the request to a particular LLM. Now this LLM, the large language model, it will be doing the planning, the decision, and the control. So the internal reasoning phase. So the intent is fix my billing error. So the reasoning will be, I need to check the bill, then compare it to the contract. That's the reasoning. Now this LLM, we know that the large language model, it makes use of the memory. It can interact with the tools. So the idea is that now LLM will not directly be interacting with the tools. So LLM will be interacting with the tools via orchestrator. So the idea is that the core components of agentic AI system like the LLM, the memory, the tool, they are directly connected with the orchestrator. So orchestrator can directly interact with the LLM, it can directly interact with the memory, it can directly interact with the tools. And that is how we have a coordination wherein the components can talk with each other via the orchestrator. So for fix my billing error, the memory will be holding the bill. So the bill will be pulled, LLM will look at it, and let us suppose there is some calculation mistake, calculator tool will be called to recalculate, and then the result will be sent to the LLM via the orchestrator, and LLM will generate a response to the orchestrator, and orchestrator will send it back to the user. And the tools, they might make use of external systems as well. So here the idea is very clear. Let us once again look at the flow. So we start with the user input, the user request, which is sent to the orchestrator. Orchestrator will analyze the intent and send it to the LLM. LLM will understand the goal, and based on the goal, it will make a plan. It will make a plan. Now, in order to execute that plan, whatever context is needed, or even to make the plan, whatever context is needed, so memory will be holding the context. So LLM might directly interact with the memory, or via orchestrator, it will get the appropriate context, or even before sending the request to the LLM, the orchestrator might make use of the memory. So the idea is that whatever user request the orchestrator got, for that user request, whatever appropriate context is there, that it will append and send it to the large language model. Large language model will do the planning, and then to execute that plan, tools will be called, and the plan will get executed, tools will be called, the responses will be stored either in the short term memory or in the long term memory. Like responses can be stored in the active context window or in the long, it depends on the scenario. And during this entire process, the orchestrator, it is continuously monitoring, it is monitoring each and every step, like okay, what tools were called, what were the response. So orchestrator is monitoring, and it is also like, let us suppose it is look seeing that the system is drifting away from the goal, then it will trigger the LLM to replan. So that is the role of orchestrator. So this is how a agentic AI system looks like, and here the orchestrator is like the spine, because it is taking care of all the components. It is taking care of the synchronization. So let us understand the architecture view, the life cycle of an action. Like, so the idea is that we start with the user input, the raw request, like fix my billing error. Now the orchestrator, it will analyze the intent, and it will make use of the memory to get appropriate context. It will append it and send it to the large language model. So the orchestrator is like the brain. It analyzes the intent, the control flow. Then we have planning, decision, and control. That is the internal reasoning. The internal reasoning is that to fix the billing error, first we have to check the bill, then compare it to the contract. Then we also have tools, memory models. So here models is a LLM. So the hands and the library. So pull contracts, pull bill from the memory, use calculator, the tool, and the model is the intelligence. And execution, whatever the strategy is made, it will get executed, the physical act of performing the task. And then we have monitoring, feedback, and replanning. Like we will keep on monitoring, giving the feedback, replanning if the we are drifting away from the goal. If error is noticed, ask why, try new path. If the calculator returns an error, the system notices, asks why, and tries a different path. So this is how it's the life cycle of an action. Now let us look at the key insight. Let us look at the key insight. So the idea is that the key insight is from science project to product. See, this is the most critical takeaway for developers and businesses. So transforming capabilities into systems. See, a large language model is a capability, but with orchestration, we can transform capabilities into systems. So with orchestration, a large language model, which is a capability, with an orchestrated workflow is a system. So with an orchestrated workflow, a large language model gets transformed into system. Similarly, with orchestration, we can transform intelligence into action. With orchestration, we can transform intelligence into action. So the idea is that pure intelligence is just thinking or making plans or making strategy. That is pure intelligence. So pure intelligence is just thinking. Orchestration turns that thought into a real world change, like money moved, email sent, code deployed. So with orchestration, intelligence is transformed into action. Similarly, with orchestration, agents they turn into products. So a chatbot is a toy. An orchestrated agent that can autonomously handle a company's customer support or supply chain is a commercial product. So a chatbot is a toy, but an orchestrated agent that can handle the company's customer support or supply chain is a commercial product. So orchestration is the key. So with orchestration, we can transform a science project into a product. We can transform capabilities into systems. We can transform agents into action, and we can transform or we can convert agents into commercial products. So orchestration is the difference between an AI that talks about doing work and an AI that actually does the work. So without orchestration, we have an AI that gives us suggestion. But with orchestration, we have an AI that is not just giving suggestion, but also acting on behalf of user. So that's the power of orchestration. So now it's very clear why orchestration is the backbone of agent systems. Real world orchestration patterns. So now we will discuss some real world orchestration patterns. The first pattern is the react. So react is basically reason plus act. Reason plus act. So first let us understand the concept of reason plus act orchestration framework. So the concept, if we talk about concept of reason plus act. So basically this is the inner monologue pattern. So monologue means the agent will talk to itself. So it's the inner monologue pattern wherein the agent will write down its internal reasoning, the thought, performs an action, act, looks at the result, observation, and then updates its thinking. So what this is what the React is. So in React, what happens is if we look at the workflow, the agent will first write down the internal reasoning. Like the agent will first think of a plan. Like it will make a plan, it will act, it will execute that plan, it will observe the outcome, and based on the outcome, it will update its thinking. And whatever the replanning it did or re-strategization it did, it will execute it, it will observe it, and it will keep on doing it until the goal is achieved. So that is what React is. In React, the agent will reason, it will make a plan, it will execute it, and based on the outcome, it will once again make a plan. So that is what the React is. So reason plus act is an orchestration pattern. Now, why is it powerful? Let us understand that. See, this React orchestration pattern, it forces the agent to explain why it is taking an action before it does it. Because in this orchestration pattern, React orchestration pattern, before acting, the agent is reasoning. So that is what. So this orchestration pattern, it forces the agent to first explain why it is taking an action before it does take an action. So reason plus act. So the first, the agent has to reason and then act on it. So that is what the React is. So that's why it's very powerful that agent will first reason, explain why it is taking an action, and then it will take the action. And this significantly reduces the hallucinations and makes the agent's logic transparent to developers. Because the agent is reasoning, the agent is explaining why it is taking an action, the agent's logic becomes transparent to the developers, and also it significantly reduces hallucinations. And hence, this orchestration pattern is like very powerful. Let us look at some examples of this orchestration pattern, the React orchestration pattern, the example of it. So we are discussing an example. So the agent is thinking, like the thought is, I need to find the user's order date. I will use the get order tool. So this is the reasoning. This is what the agent is explaining, what it will do and why it will do that. So what the agent will do is, the agent will use the get order tool. The agent will use the get order tool. And why the agent will use the get order tool? Because the agent needs to find the user's order date. So to find the user's order date, it will make use of the get order tool. So that is a thought. Now it will act on the thought. So it will call the get order tool and pass the order ID. So now the agent will receive the order information, and in that order information, order date is also retrieved. Then the agent will observe the order date, which is what it wanted. The order date was 1st January. Now the based on the response, the agent will once again think that today is 15th January and this is within the 30-day refund window. And based on that, it will make a plan. It will initiate the refund workflow. Like it validated the order and it will go for the next steps. So this is how the reason plus act works. So it's an orchestration pattern, the reason plus act. So the idea is that first the agent will decide an action to be taken and also the reason for that, why it will take an action. So in the React orchestration pattern, the AI agent will first decide what action to be taken and why that particular action needs to be taken. And then that action is executed, the outcomes are observed, and based on that, it will decide the next step of actions. Now, the next very important real world orchestration pattern is the planner executor pattern. Planner executor orchestration pattern. So basically in planner executor orchestration pattern, as the name suggests, this pattern, it separates the architect from the builder. So in this pattern, we have two separate things, like we have the planner, which is the architect. So planner, as the name suggests, it will make the planning. It will create the blueprint. It will create the plan. So the architect, the planner, will create the plan, like download the PDF, extract table, save as CSV. Like this is an example of a plan. And the builder is the executor. So in this orchestration pattern, the planner and executor, they are separated. So the executor is the builder, and this builder will follow the roadmap step by step. So whatever the planner made the plan, the executor will execute it. So it will handle the Python code for downloading the PDF, parsing the PDF, and saving it as CSV. So that is what executor is. So the workflow is very clear. In planner executor workflow, we have two separate entities. We have the planner, we have the executor. Planner is the architect, it will make the blueprint, it will create the complete plan. And the executor is responsible for executing. So in this orchestration pattern, both are working hand in hand. Now let us see why it's a powerful orchestration pattern. Why it's powerful. See, the planner executor orchestration pattern, it prevents agent from getting lost in middle of task, because the planner has bird's eye view, because the planner is just focusing on the goal, it is just focusing on creating the plan, and executor focuses on technical precision. Executor just focuses on executing the task given to it, the plan given to it, executor is just focusing on that, and the planner is just focusing on creating the plan. Because of that, there is no point of hallucination, and this planner executor orchestration pattern, it prevents agent from getting lost in the middle of task. Now let us discuss the supervisor agent. Now the third very important real world orchestration pattern is the supervisor agent. So let us first understand the concept of the supervisor agent. So this is the corporate management model. So the supervisor agent orchestration pattern is the corporate management model. So idea is very clear that okay, we have a supervisor which is the manager, and this supervisor will manage. So we have a high level supervisor which manages a team of specialized sub agents or workers. So that is what the supervisor agent orchestration pattern is. So in supervisor agent, if we talk about the concept, we have a supervisor, a high level supervisor, a manager, which will manage a team of specialized sub agents or workers, like a legal research expert, creative writing expert, data analysis expert. So the supervisor will delegate the task and review their work. So in supervisor agent orchestration pattern, the supervisor, which is a high level manager, will delegate the task to sub agents, the specialized workers, and review their work. So it is a team of specialized experts, wherein a supervisor will manage a team of specialized experts. So this is the supervisor agent orchestration pattern. Now let us understand the workflow of it. So here the supervisor oversees multiple agents or a team of specialized experts like agent 1, agent 2, agent 3. So this is the workflow. So a supervisor oversees multiple agents. So the supervisor will delegate the task and review the work of the individual agents. Now let us understand why it is powerful. Now see, definitely if we talk about supervisor agent, we can achieve massive scaling, because the idea is that we can have multiple agents and supervisor can just has to coordinate with those agents. So massive scaling we can achieve. So for multi-agent architectures, or wherein you need massive scaling, parallel work, this orchestration pattern can be very powerful. You can have one agent that is an expert in legal research and another that is an expert in creative writing. So we can have specialized experts. We can have different specialized experts which are taking care of their specialized task. And supervised agent orchestration pattern, it ensures coordination. So this is the most important thing. There is a coordination between all these individual agents via the supervisor. The supervisor ensures they don't step on each other's toes. The supervisor ensures the coordination. Now let us look at the example scenario. So we have a research agent which will find electric vehicle sales stats. We have a writer agent which use those stats for a blog post, and we have an editor agent which will check the tone, and we have a supervisor which will manage all these agents. So this is an example of an supervisor agent orchestration pattern wherein we have three different experts. Like we have an research agent which will basically find the electric vehicle sales stats. We have a writer agent which will draft those stats for a blog post, and we have a editor agent which will review the tone, and supervisor agent will just coordinate, which will just delegate the work to these agents, oversight, review the responses, and supervisor agent will ensure coordination so that everything is in sync. If we talk about real world orchestration patterns, we have something called as tool augmented agents. So tool augmented agents is also a type of orchestration pattern. Let us understand what it means, tool augmented agents. So let us first understand the concept of it. So this is the most common plugin model. So the idea is that the model is given a tool belt of external functions. So the model, the large language model is given a tool belt of external functions. So this is the tool belt, and this tool belt is the capabilities like the search, calculate, API call, database, etc. So the idea is that in tool augmented agents, the model is given a tool belt, like given external functions, and the model will decide which to pull out to solve a specific problem. So the model decides which tool to use. So if we talk about the workflow of tool augmented agents, so the idea is that the large language model will decide which tool to use. So we have a large language model. It is been given the tool belt. Large language model is given the tool belt. It is given access to all the external tools, and the large language model will decide based on the current query or the user intent. It will decide which tool to use. So if tool is needed, then it will call that tool. If a particular tool is needed, it will execute that tool, and the response it will give it to the model, and the model will generate the final output. And if tool is not needed, then it will directly generate the response without calling the tool. So this is the workflow of tool augmented agents. So now the idea is very clear. Tool augmented agents means the large language models, they have been given the tool belt. They have been given access to some external capabilities, external functions, external tools. The model will decide which tool to call when. If there is a need to call a tool, it will execute the tool and generate the response. Otherwise, it will directly generate the response. Now let us understand why is it important, why is it powerful. See, we know that large language models, they are very bad at maths. They can make mistakes. And also they don't know real-time data, because large language models, they are pre-trained models. So whatever knowledge they have, that's it. They don't know what is happening in the current scenario. So large language models, they are bad at math. They don't know the real-time data. Now tools give them the superpower. Tools give them some special superpowers. Like large language models, they can access calculator. Because of that, they become perfect in math. They can browse live web via search engine. So that is the power of tool augmented agents. Now let us look at an example to understand the tool augmented agents, which is a real world orchestration pattern. So in this orchestration pattern, the large language model is deciding, like large language model has access to the tools, it knows what tools it has access to, and it will decide which tool to use. So if we talk about the example, let us suppose the query of the user is what is the stock price of Apple times 50. Like user is trying to ask that whatever is the stock price of Apple, you just multiply it with 50 and give me the result. Now agent knows that it cannot calculate on its own. So agent will use stock price tool to get the current price of the Apple stock price, and then it will use the calculator tool for multiplication. So when the agent called the stock price tool, it got the current price of the Apple stock price and it made use of the calculator tool to get the final answer, and it will just retrieve the result. So now here the large language model, it made use of the tools, and because of that it was able to handle this query. So that is what tool augmented agents. So in this orchestration pattern, the large language model, it is given access to the tools, and based on the current query or the intent, it will make a plan, it will decide which tool to call, it will call that tool, and it will generate the response accordingly. Now let us summarize real world orchestration patterns. So if we talk about real world orchestration patterns, we can have React pattern. So React pattern is the thinker and doer. So in the React pattern, first the system will reason, the agent will reason, it will decide what action to be taken and why that action should be taken, and then it will act. And based on the outcome, it will once again react. It will reason and act, reason and act. It will do like that. So thinker and doer. First it will think, then it will do. So in React pattern, the role of large language model is thinker and doer. So first the large language model will reason, will tell that, okay, this action needs to be taken and this is the reason why this action needs to be taken, and that action is then executed. And the main benefit of this React pattern is high transparency and logic, because of reasoning, the developers and the user, they know why the large language model took a particular step. So there is a high transparency and a logic. Now the second real world orchestration pattern is the planner executor orchestration pattern. So it is like separation of concerns. We know that in planner executor orchestration pattern, if we talk about the role of LLM, we have a separate planner which will be creating the entire plan, and we will be having an executor which will be a different entity which will be taking care of the execution. So there is a separation of concerns. We will be having an architect, a planner, which will be just responsible for creating the plan. We will be having an executor, the builder, which will be responsible for just executing the plan. And here the focus and consistency on long tasks, like complex workflows, we can accomplish using this planner executor orchestration pattern. Then we have supervisor agent orchestration pattern. So here we have a high level manager which will delegate the task to specialist. So here the role of large language model is the manager of specialist. So we will be having some expert agents, specialized agents, and we will be having a supervisor agent. So one large language model will be a manager. It will be managing, supervising this team of experts, specialists. And the main benefit of this orchestration pattern is it solves the multi-domain and complex problems. And the next orchestration pattern is the tool augmented orchestration pattern. So here the large language model is given a tool belt, it is given access to the tools. So large language models knows what tools it has, and it decides which tool to call. And the benefit we get is we are extending the AI capabilities, because we know that large language model, it is not good at maths. Large language model, it does not have access to current information because it is a pre-trained model. So with tools, we can call search APIs to get some news updates, which we can give to the large language model. Large language model can make use of external calculators to precisely calculate. So we extend the AI capabilities. Practical example. Now let us look at a end-to-end practical example, like how orchestration works, like how with orchestration we can turn skills into systems. Let us look at a practical example. So the task we want to accomplish is refund a damaged coffee mug. So let us suppose we ordered a coffee mug and we were like we got delivered a damaged coffee mug. So now we have a damaged coffee mug, we have to return it and get the refund. So the task is refund a damaged coffee mug. Now let us understand the orchestration flow. So the first thing is understanding the intent. That is the natural language understanding phase. So the orchestrator will make use of the LLM to parse the raw text. So the raw text is refund a damaged mug, coffee mug. So the orchestrator will just pass this raw text to the large language model, and the large language model will do the understand the intent of it. So the large language model will understand that okay, for this particular prompt or the query, the action is refund. The object is coffee mug. The reason is damaged, and it will also identify some missing information like order ID is missing, and it will give it the first priority. So the first priority is to find the order ID. Then, once the we understand the intent, then the orchestrator what it will do is plan steps. So the second is the plan steps, the blueprint. So instead of guessing, the orchestrator generates a logical sequence. So here the logical sequence is search for orders, confirm mug in order, check 30-day damaged goods policy, execute final transaction, notify user. So this is the plan. So the orchestrator will make use of the LLM to create a plan. And once the plan, the blueprint is created, then the third step is retrieve order, like get the order. So to retrieve order, we can make use of either the memory or the tool call. It depends on the context, whether the order information is there in some database, the memory, or some APIs we have to call. So the system will fetch user's recent order. So the orchestration logic, now let us understand that. So if multiple mugs are present, if multiple mugs were bought recently, the orchestration pauses to ask the user which order was this for. So this is the role of orchestration, wherein it is clearing the confusion, because let us suppose while fetching the user recent order, the system got to know that in multiple orders the mugs are present, like mugs were ordered multiple times. So if multiple mugs are there, orchestration will just pause the process and it will ask clarifying questions from the user. Which order are you talking about? So it refuses to move to step 4 until the data is unambiguous. So this is the key. So while retrieving the order, orchestration, it ensures that the correct order is identified. It will ask clarifying questions from the user. And once the correct order is identified, the orchestration will validate the eligibility of the order, the guardrail. So it will look at the purchase date, the order date, to see whether it is less than 30 days. and it will also look at whether the item not already refunded. If these checks fail, let us suppose if the order is not eligible, there itself the orchestration logic will stop to prevent the fraud. Otherwise, it will go to the next step. If the order is valid, it is eligible for refund, then the orchestrator will call the refunder tool, the action. So it will call the payment gateway API. So it will call a tool called issue refund with passing the order ID, the amount. And now here, the role of orchestrator is it will keep on waiting until it gets a valid response. It will wait for server response. And once it gets a valid response that, okay, refund was done. So after calling the refund tool, the orchestrator, it will monitor success and confirm, which is the feedback loop. So the idea is that the orchestrator is waiting for API response. If the API response is success, it will tell the user that, okay, refund successful, this much amount will be credited to you in 3 to 5 days. And if it was a failure, like when we called the refund tool, something wrong happened, then orchestration will handle the exception. Either it will retry, or it will go for an alternate path, or it will bring human in the loop. And out of all this, one of the very important role of the orchestrator is the pivot. If there is any change in the plan, orchestrator will replan. It will ensure graceful recovery. Let us suppose there is some transient error, like some server error, some timeout, then it will handle it. Some policy error, like it, then it accelerates to a human agent, creating a support ticket with all the context gathered so far. So the graceful recovery. So now we got a very good idea that how the orchestration works. Like we looked at a practical example, and now it's very clear that how orchestration turns skills into systems. So the key takeaway from this lecture, whatever flow we discussed, like the key takeaway, if we talk about, the intelligence is not just in the language, it is in the control logic. So see, the idea is that we know that the core unit of intelligence is the large language model, because in an agentic AI system, we get intelligence from large language model. And that is what I want to say, that intelligence is not just about the large language model, but it is more about the orchestration. It is about the control logic. So very, very important insight we got, a very interesting insight we got. Intelligence is not just about the large language model, rather it is more about the control logic, the orchestration, the orchestrator. The orchestrator ensures that the mug isn't refunded twice. Orchestrator ensures the user is not lied to factual check. Orchestrator ensures companies' policies strictly followed. So with orchestration, we have a safe and correct response. So now it's very clear that intelligence is not just about large language models. Intelligence is more about the control logic, the orchestrator. So with this, the importance of orchestration is very, very clear to us. So finally, we completed this lecture. In this lecture, we discussed in some good detail about the orchestration. We saw that orchestration is the central nervous system of agents. Orchestration means planning, execution, monitoring, and adaptation. Orchestration enables multi-step reasoning, tool usage, and real-world reliability. So an agent is only as good as its orchestration. Without orchestration, we are just building some demo project or a toy. But with orchestration, we are building a production system. So I hope you got a very good insight, some good understanding of the concepts in this lecture. So do subscribe to our YouTube channel ScaleUp University for more such interesting lectures and courses. Thanks for watching. Thanks for your time.